Welcome, everyone, to the AWS Certified Solution Architect 2022, a completely free AWS certification course to help you pass the AWS Certified Solution Architect Associate exam here in 2022. My name is Michael Gibbs, and I am the founder and CEO of Go Cloud Careers, and I'm honored and excited to be with you to talk about AWS Certified Solution Architect Associate Training. Many of you people and many of the folks out there know me as the guy that gets everybody cloud hired. And what we do as an organization is really train people to build their best cloud architect, cloud engineer, and other technology careers. And there's a lot that goes into these careers, so many things. But one of the things that also is part of this is improving our resume. And certifications are really great for improving our resume to help us get the interview. So that's why we have a completely free AWS Certified Solution Architect Associate Bootcamp. Now, I'm going to tell you this. We are not going to run this like a traditional certification class. We will give you all the information you need to get certified, but we're also going to work very hard to make sure you know the things that are on certification exams only that you can't do in the real world versus things that we would do architecturally to get you hired as well. So while we will cover it as a full certification course, we will also say, in this particular case, this is what we're talking about because it's certification related, but in reality, you won't use this. And the reason why we're so focused on this is when you go on cloud architect interviews, the employer is going to care that you know what's done in reality, not what's done on certification. So we will talk about the certification, but our goal is not just certification, it's getting you all cloud hired. So this is a free full AWS course, and we're going to begin by talking about the AWS Certified Solution Architect Associate. Let's get you all certified. Let's get you all knowledgeable. And any of you guys that want to learn more and get cloud hired, we can help you too get cloud hired, and we're thrilled and honored to do so. But in this week, we're going to cover this AWS Certified Solution Architect. Now, before I begin, I want to tell you about some housekeeping things to let you know about. There is an option for you to do labs, lots and lots and lots of labs. And we've put them in a separate course for you. And you can register for this course absolutely free. Absolutely free. And you can download it and you'll have access to these great, wonderful labs that are done from my team. On this week, when we are live, we're going to focus exclusively on teaching you how things work, the architecture, the principles, how to design it, and everything you need to know. But we'd still like you to do some things in the back end, some practice exams, and go do it. Guess what? Download that course. The link is in the description below. Now, tonight, after training, we've got me and my brother, Alonzo. He's not technically my brother, but we consider ourselves to be brothers because we're so close. We will be running a really great show, and we have a special guest, Eva, who's got a personality that lights up a room, and we're super excited to talk to her and bring her on tonight, and it is going to be a wonderful, 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 miraculous, and exciting experience. And one last thing that I'll mention, there's a companion ebook that if you don't have it, download it. The link is in the description below. Make sure you got it and you get that link. And if anybody here is interested in not only getting certified, but actually getting hired after getting certified, we have 30% off of our Cloud Architect Career Development Program. The link is in the description below, and my team will provide it as well as put on a banner. And every single day I've got a student that says, Mike, I got my first cloud architect job, or I got promoted into this enterprise architect job. Whatever the case is, we get people hired or promoted every single day of the week. And I'd like it to be you too. So if you'd like to train with us, we've got 30% off of all of our training things. But this week, we are here to do a completely free AWS Certified Solution Architect 2022 Bootcamp. So with that, let's begin. Before we begin, if you can all give me one hashtag and tell me if you can give me a hashtag cloud hired, and in the same line, if you can tell us where you're from. I'm sitting here right now in Port St. Lucie, Florida. Chris is in St. Petersburg, Florida. My teammate Lou, who's also on this call, Leo is over there in Brazil. And where are you all from? London, DC, India, the Netherlands. Tom, love that you're here, Tom. Connecticut, Houston, Cornwall. Haven't been there in a little while. Chicago, cloud hired South Africa. Loving this. Atlanta, Okay, Sri Lanka. This is fantastic. Okay, all over the world, from Nigeria to England to New Zealand. Wow, Sudan, Waco, Texas. Okay, this is just fantastic. Cloud hired, and that's why we do what we do. I am absolutely in love with this. So, to get a group like this of amazing, amazing people from all over the world makes us so happy and so proud. Wow, all of you everywhere in so many great places. I am loving this. We love having you here. We are thrilled to have you, and we are going to make this a great experience. So please join us tonight on the special show. And we're going to get started, and we're going to have lots of fun. So we will cover it from a certification perspective and also from a practicality perspective as we go through things. If you guys need something, let us know. So what we're going to do is we're going to do 20 minutes of training and 10 minutes of lessons, just like a real boot camp. 20 minutes of training and 10 minutes of lessons. So here's 10 minutes of questions, because I don't want anybody lost. This is going to be a great experience for you. Ask your questions. Let's get you all cloud hired. So let's begin, and let's start to have some real fun with this. So let's begin with the AWS cloud and how it's organized. So the first part of this discussion is going to be the AWS cloud and how it's organized. And we're going to talk about the following: regions, availability zones, local zones, and edge locations. So while we talk about AWS cloud and how it's organized, we're going to divide it into regions and availability zones, local zones, and edge locations. So we'll get into them in more depth, but let's first look at it from the large geographic area. And as you can see in this graphic, a region is a very large geographic area, kind of like a continent or part of a continent. You can see it by this big giant green box. That's a region. Now, let's say you've got a continent or part of a continent. Just because you've got a large geographic region doesn't mean you've got any servers or storage or any computer, anything. But where do servers and storage get placed? In all environments, they get placed in a data center. So whether we're building our own data center as a business or we're dealing with a cloud provider, we're still dealing with the same data centers. Nothing's really changed. So what we have is something called an availability zone. And for the majority of the cloud providers, an availability zone means a data center. So it's just a building that's full of servers and storage and security devices, routers, switches, air conditioners. And we'll talk much more about data center as we get through that course. But now you know, region is a large geographic area. And an availability zone is nothing more than a data center. So obviously in every region, big area, you have lots of data centers. Now you know how that works. Now let's talk about a local zone. Now, when we're getting to cloud computing, it's different than regular computing. So let's talk about why it's so different. And I want you to think about this. If I had a wire with you, and we needed a wire to go from New York to London, that's a pretty long wire, right? Now, as we send photons across the wire, because it's a fiber optic connection, so you've got a laser, and what is the laser sending? It's effectively photons or light. It takes time to take that photon from, say, New York all the way to London. It takes milliseconds, 3, 4, 5 thousandths of a second. Now, you might say, that's pretty fast, Mike. And I'd agree with you. It's incredibly fast. It's a lot faster than I can paddle a boat to get to England from Palm Beach, Florida, or New York, or whatever the case is. But it still takes time. Now, when we run applications, some applications are time sensitive. Imagine a financial trading application that buys and sells stocks automatically based upon news. So in this particular environment, there's some good news that comes out, which causes all the banks to buy the stock, which causes those people buy the stock, the price goes up. So now let's imagine we can get that bank to buy that stock at the nanosecond that the good news occurs, before the rest of the world finds it and buys it. It means that our bank can buy the stock cheaper and make more money. So there's lots of business applications that are sensitive to latency. And when we go from our data center, which is attached to our building, to the cloud, we lose a lot of performance. So think about it this way. If all your servers are in your house, how long is it going to take you to reach your servers? None whatsoever. And for many businesses, they have a house for their servers. It's called the data center. It's a big giant building filled with servers and storage and routers and switches, etc. And because it's local, it's fast. Now all of a sudden we go to the cloud provider and it's 1,500 miles away from where we're located, or over 200,000 kilometers away. Guess what? Guess what? There's latency. So there's a latency problem going to the cloud, which may be a problem or may not be a problem based upon the business. So what did AWS do? They came up with the concept of a local zone, which is realistically speaking, edge computing. And what this does and allows you to do is as follows. It enables you to connect to a data center that's midway between your organization and the cloud. It's called a local zone. It enables you to have computing power closer to you, the user. And what happens is people have the opportunity to opt into a local zone. So instead of just connecting to the AWS availability zone in your region, they have a data center that's closer to you called the local zone. So you'll opt in to use the local zone. In this local zone, what will you do? You'll place your EC2 instances in here, for example. You'll place some load balancers in here, your container environment. And some of these local zones are so cool. Guess what? Some of these local zones are so cool that they even let you do the file system for Lustre, elastic load balancers, map reduction functions, elastic cache, databases. So realistically speaking, we can now even get a direct connection to a local zone. So think about it this way. A local zone is something in between you and the entity. So if I were to graphically show it to you, here's what happens. You've got your AWS region, which again is that large geography. Now, inside of each region, you've got multiple data centers called availability zones. Now, this local zone that we have here is an extension of the region to get the computing power closer to the user. And that's what we're talking about with regards to local zones. So that's how they work. Now, in order to use these, what do? Realistically speaking, you enable local zone, you extend your VPC into the local zone, and this is where you're going to build and run your really low latency applications. So now you know the point of a local zone. It's a midpoint between your organization and the cloud. And what we'll do before we end this section is architecturally, we'll walk through the local zones and I'll explain to you why it reduces latency and how it improves performance, because I want you all to really, really, really know it. So let's talk about the last one, which is edge locations. Now, an edge location is where the content delivery network is that AWS provides, called CloudFront. And an edge location is the place where users get local internet access in most major cities. Now, the point of an edge location or a content delivery network is to improve web performance. And the reason content delivery networks work is, and then I'll show you, we'll map it out geographically. If you send data on the internet does not have to deliver your traffic. Internet traffic is called best effort. So there are no guarantees in performance on the internet. Now, if I call AT&T and say I would like a 10 gig private line between New York and London, I know I'm guaranteed 10 gigs between New York and London. But on the internet, I can buy a 10 gig link to the internet. And while I will get 10 gigs to the internet, doesn't mean that the internet's going to supply me 10 gigs. So when we talk about edge locations, what we're talking about is the content delivery network. So content delivery networks do two things. They allow for caching, but they also allow for private networking. So I'm going to show you how it works. In this particular environment, you can see we've got our large geographic area, which is an AWS region. You can see we've got lots of data centers called availability zones in these AWS regions. Great, right? Awesome. Now here, as you can see, we extend the regions to something called an edge location. Now, Azure would call this what it really is, which is a point of presence, and I'll explain to you what that is, but AWS calls it an edge location. And here's what happens. AWS has a private network to these edge locations. So it's not internet network, it's a private network. So what'll happen is when a user wants to access the internet, they will go to the edge location. And the edge location will either serve them, and we'll walk through that in a minute, or the edge location will use a private network, not the internet, a private network, to cross from the edge location to your AWS VPC. It rides over the AWS private network, the content delivery network. So it's a private network, and that's how it improves performance. And by doing that, that's how we're doing what we're doing. So I'm going to show it to you a little differently. Now I'm going to take it from the user's perspective. I've got a user on this top blue user. This user wants to go to www.gocloudcareers.com. She wants to become a cloud architect. So user over here in the blue goes to www.gocloudcareers.com. Now they hit their edge location, and guess what? For some reason today, nobody in that geography decided to go to www.gocloudcareers.com. So the user's request hits the edge location. Now, the edge location does not have it. So the next thing that happens is the edge location sends it to a regional cache, which is somewhere in the midplane. It says, hey, do you have it? And of course, the regional cache doesn't have it. So then the message is sent to the source. Say it's either static content coming from S3 or dynamic content coming from the EC2 instances. This information is then sent across the private network, content delivery network, so it's got better performance than internet networking. Then it gets pushed to the regional cache, who stores it, and it gets sent to the edge location. And now the user gets access to www.gocloudcareers.com. Now, 10 minutes later, somebody else wants to go to gocloudcareers.com, and guess what happens? They make a request. The request goes to the edge location in their city, and poof, it's there. The response is there. Now, the next user wants to go to www.gocloudcareers.com. They go to the edge location, and it's there. So what you can see is it reduces the load on the servers, it reduces the bandwidth on the servers, and it improves performance. Now, let's say that blue user up top, she's in Palm Beach. Now, the gray user in the center is in London. Now, the gray user that's in London goes to www.gocloudcareers that day, and guess what happens? They hit the edge location, and it's not there. So the edge location sends it to the regional cache, which doesn't have it. It sends it back to the source, which sends it back to the regional cache, rides the private network to the edge location, and now goes to the user. Now, that was the first user in London that couldn't get in, but now another customer in England wants to go to www.gocloudcareers. They hit that same regional cache, and they are there. So as you can see what's going on, the caching, the content delivery network improves both the performance in terms of private networking and caching. So that's what we're talking about. So before we get to the next section, what did we talk about in this class? Well, we talked about regions being a large geographic area. We talked about availability zones being a data center. We talked about edge locations being used for the content delivery network. And we talked about one last thing. We talked about local zones. So let's walk through a little architectural whiteboarding real quick so we understand what we're doing with the local zones and how it works and how it matters and why. So let's go to this beautiful whiteboard that I just created over here. So let's say this is where you're located. So this is the premises environment, premises. So this is where we are at. This is, this is the building where we're at. This is where our data center was. We've got lots of cool stuff. And we decide that we're going to put some stuff in the AWS cloud. So here's our AWS cloud. And we've got good networking between them. We have a direct connection between us. Oh, this is great, 100% perfect. But the problem is this might be 5 milliseconds of latency in between us. And do I really want that 5 milliseconds of latency in between us? Well, some applications, yes. Other applications, no. And if the application can't tolerate it, this won't work on-premise to the cloud. So in these particular cases, that's what we're talking about here with regards to the local zones. It's sticking another data center in between you and the cloud. So you can put some of your stuff in the local zone, and then the rest of your traffic is in AWS. And by doing so, what you can actually do is as follows. You can have the AWS local zone, where we put some of our stuff, and we can put the AWS the rest of our stuff in our VPC, which is sitting there in the AWS cloud. So if that makes any sense to you, that's what we're trying to do here. So what I want to do is open it up for questions for about 10 minutes. And then after that, we'll go back to the content. But I want to make sure everyone has a chance to ask a question. So we've got 10 minutes of questions. My team, all the blue wrenches that are here, they're aggregating questions so I can answer a few of them. We'll answer questions for 10 minutes, and then we will get back to the content. Is an edge location part of a local zone? No, they're two different environments. Now, edge locations are where the users access the CloudFront content delivery network, and local zones are an extension of a region. So kind of keep that in the back of your mind. So edge locations are different. Now, what are we really talking about with a content delivery network or an edge location? We're typically talking about something that's called a point of presence. And Azure calls it a point of presence. And what is a point of presence? Let's be real. If I've got AT&T coming into one building and Verizon coming into the building and NTT coming into a building and Vodafone coming into a building and all that big internet service providers coming into a big building. And inside of this big building, we run cables from service providers to service providers. That's called a point of presence. And what happens is that's where your cross connects occur between different internet service providers. So by doing that, it's the perfect place to actually also put your content delivery network. So there you go. So now you know. Sig Wolf, if a local zone goes down, well, you use two of them. So that's the thing. So when it comes down to it, Sig, we always must assume a single cloud is never good enough. A cloud is not good enough, and it never can be, because, and we'll tell you why, a single cloud is a single point of failure. And we'll cover it so much more later when we talk about building high availability architectures. But if you're only using a single location and that location goes down, all your systems are down. So that's obviously not a good solution. So you need to use more than one. Lucas Caruso, what is a VPC? We will spend a whole day on that, but realize a VPC is basically a virtual private data center. And Mufaz, can you say a local zone is a mini data center? No, you can say it's a real data center. Sure. So basically, local zones contain AWS harsks racked up, and so AWS local zones only have AWS stuff in there. Now, their stuff is your stuff. So when you put something on AWS, it's their physical hardware that you're renting, but it's still your virtual machines in there. What does a local zone consist of? It's a data center. So it includes routers and switches, which do the routing. It includes servers. It includes storage. It includes physical load balancer, hardware firewalls, intrusion detection, intrusion prevention systems, VPN concentrators, as does every other data center and cloud in the entire world. What is the connection between an edge location and a local zone? Absolutely nothing. A region is a large geographic area. An availability zone is a data center. An edge location is a data center that has the CloudFront content delivery network. And a local zone is a data center where you can put your stuff that resides in AWS. So it's still going to be AWS things, but you'll be able to create your AWS virtual machines in there. Chris, you want to go to the next one? Abhishek, what's the difference between a local zone and an AWS? A local zone is a data center owned and operated by AWS. And it's owned and operated by AWS in order to get you closer to AWS services than not. So instead of connecting all the way back to the AWS cloud, it's another AWS data center, which is part of the AWS cloud, just closer to you. So that's all it is. It's a data center between you and them. Why can't you put all your data in a local zone edge location? AfriP, and I haven't seen you in a long time, and I am so thrilled to see you. You could put all your data in a local zone. In fact, AfriP, we don't need to deal with the cloud at all. We could put all the data in our data center for the best performance, highest availability, and highest security. So AfriP, what is the local zone? The The whole point of using the local zone is to try and get closer to normal data center performance, because cloud performance is slow with high latency. So the whole point of the local zone is, look, if we're local in our data center and everything's really great, and we go to the cloud and everything's kind of sluggish with high latency, the local zone is just a midpoint, so you don't have to deal with the bad cloud latency. And it's a way to get almost as good as if you put the stuff in your on-premise data center. So what's better than all of this? Have your data center and connect it to the cloud. On a hybrid cloud, you get better performance, better scalability, and better availability. Who is going to build the local zone? We're dealing with cloud computing. So what is cloud computing? It's nothing more than renting somebody else's network in a data center in a virtualized environment. So who's going to build it? AWS is going to build it. Now, when AWS builds these things, these buildings are a fortune. The data centers are a fortune to run. So what do? If they buy a server for $1,000, they obviously charge you more than $1,000 to operate that server. So yes, the cost of renting stuff on the cloud is sky high compared to buying it yourself. Having said that, the maintenance costs on the cloud are so easy, and the personnel reduction on the cloud is so easy. So even though the cloud's much more expensive for certain things, it may be cheaper in most cases for lots of customers anyway. How long does an edge location maintain the cache? That is related to the time to live you set in your content delivery network, and you can tune that or adjust it. And when we get into talking about content delivery networks, we will talk about the benefits of raising the TTL in terms of scalability. And we will talk about what happens when you raise the TTL in terms of fresh content. So yes, that's up to you. Is the edge location the same as CloudFront? CloudFront sits inside of the edge location. So the edge location is a data center. And in this data center, they've got a private network that goes back to AWS, which means high performance networking back to AWS. And it has a network of caching servers that sit inside of this data center. Are there benefits of putting something in a local zone within a geographic area? Yes. Here's the reason. You put it on the cloud, it's far away, which means low performance, sluggish latency. If you put it in your data center, it's instant performance. So if you can't tolerate the performance of the cloud because you need better and you don't want to run in your own data center, that's when you use the local zone. No, edge locations are another type of point of presence. Edge locations and local zones are two separate things. So I'll do it again. Region, large geographic area. Availability zone equals data center. Local zone equals another data center that's where your internet service provider, which is where you put your stuff. And an edge location is another set of data centers owned and operated by AWS where they put the CloudFront network. So edge locations don't reside in local zones. You understand that regions and AZs you select, but the edge locations, are these automatically designated? Well, it's a content delivery network, so there's about 220 locations. So it will automatically be spread across those 220 locations because that's the way content delivery networks work. And it's really going to be determined. What happens is when we set up a content delivery network, it creates a new DNS address. And when the user comes in, they get routed via DNS to the local location for their content delivery network. And the difference between an edge location and a content delivery network, a content delivery network is a content delivery network. An edge location is where it's at. A content delivery network is a network, which means routers and switches and links, 10 gig links, 100 gig links, multiple 100 gig links put together in, Ether channel or port channel or link aggregation group. So it's a big high performance network, is a content delivery network that also has servers on each end that cache. Now, whenever you have a network, it has to be put somewhere, right? I mean, I can't just stick my net routers and switches firewalls in the middle of the street, the ocean, or the sand. So they get put in a data center. So the edge location is where you put all that stuff. It's a data center for the content delivery network. Any difference between a point of presence and an edge location? Well, a true point of presence, true point of presence is only where internet service providers connect to each other. Now, having said that, were you going to put a content delivery network where the internet service providers connect to each other? So they're not technically the same, but in reality, pragmatically, they are the same, but they're just not technically the same. Point of presence is where your ISPs meet. Now, if you're going to build the content delivery network, do you put it where your ISPs are, your internet service providers? Yes. If not, you'd have to build a network to go back to the internet service providers. And we will spend about 2 hours covering content delivery networks one day as part of this week because it's absolutely that critical. I'm not going to be able to go through a full thing inside of 5 minutes. Do edge locations provide services to AWS? Well, if you are AWS in an AWS data center, they only provide services to AWS. But if you go to any other content delivery network, they provide services to whoever uses them. Like Akamai is a content delivery network, Cloudflare is a content delivery network, Google's got its content delivery network. There's thousands of them out there. So I think we can do one more, and then we have to get back to the content. And any questions that are coming, it looks like there's a bunch on content delivery networks. As I mentioned, we will spend 2 hours one day this week discussing CloudFront and content delivery networks. So I want to make sure that we do that in the right time and keep everybody moving so that everybody learns a lot. Does it mean so? Well, can do. You can choose to use local zones or not local zones. So they're not necessarily used. Edge locations, you can choose or choose not to use. And again, that's up to you. You can build a website without a content delivery network. And you can build everything on premise without the cloud, period. Or you could build it all on the cloud, or you can put it through a local zone. So no, not everything passes through a local zone or edge location. The only thing that goes through an edge location is the content delivery network traffic. And the only thing that goes through a local zone is what you choose to put there. But they don't happen automatically or dynamically unless you tell them to do so. Don't forget to register for the lab demo videos if you want to do some labs. And then we're going to get back to the content. But before we do, if you can give me a hashtag cloud hired, then we'll get back to the content. I want to know that you're awake, alert, and oriented. You're not falling asleep because, this stuff gets pretty challenging. And I want you all to have the absolute best experience. So now let's talk about the VPC. We're going to introduce the AWS Virtual Private Cloud now. And like I said, we'll introduce it now. We will dedicate a full day to the AWS VPC. But I want to introduce it right now, just enough to be able to go through the content that we actually need to. And then we'll go through much more later. So what is the Virtual Private Cloud? Now, if you ask certification providers, they're going to tell you it's a place to, it's a virtual private network. But here's the thing. It's not. A virtual private network is as follows. You take two locations and you create a tunnel in the internet or in some environment to make sure that it's secure communication. What we're really talking about here is we're talking about a virtual private data center. What is a data center? Well, a data center is a building, a big, beautiful building that's filled with servers and storage and DNS servers and firewalls and VPN concentrators and routers and switches. Oh, wait, that's what your virtual private cloud is. It's your data center. It's where you put your servers, your storage, your firewalls, your VPN devices, all in there. So the virtual private cloud is really a virtual private data center, which is where you put all your computing. So let's think about it this way. Get rid of the cloud. You build a giant building. In this giant building, you bring in megawatts of power. You bring in two power companies because you can never have a power failure in a data center. You bring in two generators into a generator to make sure that if the power fails from both power companies, you have generators. And then you put some battery power systems in to make sure that if your power companies and your generators fail, you still got battery backup. So that's what goes into a data center. Then you put these massive air conditioners and etc. into the data center. Inside there, you have racks. And you fill your racks with servers. And then you fill your racks with storage area network equipment. And then you fill your racks with physical load balancers. You fill your racks with firewalls, VPN concentrators, switches, and that's your data center. Now you go to the cloud. Everything gets moved to a virtual data center. So instead of building your data center and putting in all your servers and stuff, now you call AWS and you say, hey, I need a data center. And they say, here, You can go to our webpage and you can carve out your own data center on us. Now think about this. You're carving out your virtual data center. Data center in your own building is 100% under your control. You own it. So in your own data center, you can make it as big and fast, as powerful as you can. Do you have any control over the cloud? No. So you got to stick with whatever they give you. So the virtual private data center is where you will put your stuff on the cloud. Stuff, as I like to call it. And the reason I like to use the stuff is it's a word I got from my mother-in-law. And it really makes sense. It's just all the things you put here. And so let's look at this and really make it into sense. What is a cloud? It's a virtualized network in a data center. So here we've got an AWS data center here. We'll call it the cloud. Because all a cloud is, you take a bunch of data centers, you install a control plane, and it orchestrates where your stuff is put. All my students in the Cloud Architect Career Development Program build the cloud from scratch. You can't be a cloud architect if you don't know what a cloud is or how to build the cloud, so all my students do it. But when they build the cloud, what are they really doing? They're building a data center environment. So let's say we took our data center, and if we decided to chop our data center into the blue customer called VPC1, the green customer called VPC2, the peach-colored customer is VPC3, and VPC4 is just another customer, right? So all that we've done in a cloud computing environment is taken a physical data center, shrunk it down, virtualized it, and then sell it to other people as a virtual data center. So that's what we're really talking about here, is the cloud. So your VPC is your own virtual data center inside of somebody else's public network. So this AWS cloud is a shared network. Now, does the shared network perform as well as a dedicated network? No. But the shared network is very agile. See, normally speaking, and here's the reason we've gotten to cloud computing. I want to go build this data center. I hire a bunch of $200,000 Cisco certified internet experts. I hire a bunch of maintenance people. I hire a bunch of equipment management people and operations people, and it's a big thing when we go build it. Now, it takes millions and millions and millions, if not billions of dollars to build some of these data centers. I need equipment. I call Dell 6-8 weeks later, it shows up. And now I've got the cloud. Doesn't perform quite as well, but now I need a server and I can do 3 button clicks and in 10 seconds have a brand new server. Wow, that's agility. Now I don't need all these $200,000 CCIEs because the cloud is silly easy. Okay, that's looking more attractive. So we've gone to the cloud for agility purposes. It's so much more agile because we're renting out something that's pre-made that has capacity when we need it. So that's what we're talking about with the VPC. Now, when we're talking about cloud, we're really talking about 3 basic architectures. And some of the architectures are insane and some of them make sense. And we're going to talk about the types that we will use. And yes, I'm saying some of the things, hey, wait, with the shared network, if you hack into the shared network, do you hack into all the customers? Yes, you do. Absolutely soothing relaxation. So that's the thing. When we're dealing with the cloud, it is less secure than the data center, because if you hack into the cloud provider, you hack into all of their customers as opposed to a data center. So keep that in the back of your mind. We are dealing with these kind of things. So, but the cloud is so agile that we're going there. So we're going to talk about the 3 kinds of cloud architectures. We're going to begin by discussing the hybrid cloud, which I believe is fundamentally by far the best and most appropriate cloud architecture. And here's what a hybrid cloud is. We have a data center and we connect that data center to 1 or more clouds. Now, why is the hybrid cloud so great? Well, let's think about it this way. If we have our own data center, let's say we're a hospital and we've got some of our applications in the data center, and then we also put our applications in the cloud. If AWS gets hacked, for example, or AWS has a power failure, since they apparently were completely taken down by a power failure last year, or AWS has an impaired network, which takes down their entire global network. With the hybrid cloud, it doesn't matter because that hospital has patients. It's got their own computers locally. Their patients are being taken care of. And if AWS is down, who cares? So hybrid clouds are designed for high availability. Guess what? Hybrid clouds build the best performance. Here's the reason why. The data center is local. The cloud is far away. So when we talked about local zones trying to help us out by making the poor performance of the cloud better by sticking some midpoint cloud data center in between us and then, that's a Band-Aid. A hybrid cloud, we have our own data center and we connect to the cloud, is perfect. So organizations that have already invested a lot in technology, yes, awesome, hybrid cloud. Do some of the workloads locally, the things that need higher performance, use the things in the cloud that you can't do locally. It is brilliant. So you can connect, you can do a hybrid cloud, meaning just a traditional data center, or hybrid clouds involve using cloud services like OpenStack from Red Hat or Nutanix. And you can build and install the same cloud on your own physical data center that the cloud providers would have. And then you could connect your cloud to their cloud. So that's a hybrid cloud. It is used for ultra high performance applications. It is used by organizations that have critical requirements such as medical institutions or banks, highest performance and most flexibility. Cloud provider raises your rates, you can go right back to your data center. So that's a hybrid cloud. And what's it look like? It looks like this, where you've got your corporate data center, you've got a connection to the cloud, you've got your virtual private data center, and you've got your stuff spread across multiple availability zones or data centers. This is a very common cloud architecture, high availability, high performance, and good for anything. Now, here's the next thing. We're going to talk about the pure cloud and the multi-cloud. A pure cloud is this. You brand new start your business and you call your cloud provider and say, hey, I'm going to stick it all on the cloud. Where is this good? Let's say you've never had any technology before. Well, you've got a decision to make. Do I buy and run my own, or do I go to the cloud? Now, in many cases, the cloud's more agile. So for organizations that don't have any tech already, they may just want to go to the cloud, which means they don't have anything to buy. They've got long-term scalability. They've got much more rapid deployment. And guess what else? On the cloud, they're going to pay for what they use or what they turn on, provision, and use. And in the data center, they purchase everything up front. So keep that in the back of your mind that in the cloud, it's so much faster. Now, here's the other advantage to the cloud. In my data center, if I want to connect to 10 different partners, I'd either get 10 different VPNs or 10 different direct connections. But if I'm on the cloud and my customers are on the cloud and my partners are on the cloud, I can connect through them to the cloud. So a pure cloud environment is often cheaper and it's much more agile. Now, when it comes to pure cloud environments, there's two ways to do it. There's the insanity way, and then there's the way you should do it. The insanity way is something, and it's part of this course that I have to teach you, that if you want to build a high availability network, according to AWS, if you use 2 availability zones, which is 2 data centers, that'll get you to 99.99% available, meaning you'll have less than an hour of downtime per year. But we would, if you do a pure cloud and you stick it all in AWS like that, and AWS has a power failure, a network problem, or realistically speaking, that shouldn't take down a network, but it has. But if AWS is hacked, or AWS has a network issue, or AWS has a problem with the control plane or the orchestration of, what servers go where, it doesn't matter how many availability zones and regions you use, the whole cloud is dead. So a pure single cloud is for insane people or organizations that don't care if their systems go up or go down. Use a single cloud, like a pure cloud for a hospital environment, and watch that cloud go down and people will die. Use a single cloud for a banking environment where 1 minute of downtime costs $10 million. Get a 5-hour outage from a cloud provider and you will have a major problem. So a single cloud is a single point of failure. We've told people for years never to do it. For the last 25 years, when you've trained network architects, you say, never use a single provider, always use 2. Now, I'm going to tell you this right now. AWS is still recommending them as a primary, but I'll also tell you that Azure never recommends single cloud. And I'll also tell you that Google never recommends single cloud. So for the exam, single clouds are beautiful. But when it comes to actually working as a cloud architect, A single cloud is a single point of failure. So your architecture options for high availability will be hybrid cloud, data center and cloud. Why? The cloud goes away. You still get your data center. No big deal. Pure cloud, you're on a single cloud. Cloud goes away, you got nothing. Multi-cloud, you're on AWS, Azure, and Google. AWS goes away, you still have Azure and Google. No big deal. So when it comes to high performance, we like to say 2 is 1 and 1 is none. So kind of keep that in the back of your mind when it comes to architectural principles. 1 is none and 2 is 1. So how do you really do it? Now imagine you had a data center, like a hybrid cloud, and then you connected that data center to 3 clouds. Now what's it going to take you down? You're going to have to lose your data center and lose 3 clouds. So we will get through lots of scenarios through the time, but that's what we're really talking about. We are really, really, really talking about how do we build the highest performance systems that are ready for use when we need it. So what's a pure cloud look like? It looks like this. Very simple. You got your building, your direct connection, and then it takes you to your cloud. Now, let's map out for a minute before we get into more just the architectural principles so you get to see what it is. So let's say we've got this. Got our data center, right? Now let's say we take our data center and we decide to install Nutanix on it. Great, great, great cloud software. Now let's say we've got this. We've got AWS over here, got Azure over here. Got a connection between them. Now for you to have a problem, AWS has to go away, or this link has to go away, or both. Azure has to go away. And pretty much you need an earthquake to take this data center down. And if that happens, you're down. But which do you think is easier to happen? One of these links failing? One of these clouds failing? Or 2 public clouds and a data center? All operated and maintained by different people. And that's why, architecturally speaking, we're really talking about hybrid clouds and multi-clouds for anything that requires good performance. We covered 20 minutes. We're going to start talking about connecting to the cloud real soon, which gets real fun. So before we get into the networking, let's see if we've got any more questions that we can answer for 10 minutes. So Chris, if you want to find me some, does a VPC inside a shared network have its own security? Yes, Asim, each VPC will have its own security. Now, having said that, if that cloud gets hacked, you're still getting hacked because it's a shared network. But what we're talking about is inside of your VPC, we're going to put firewalls, VPN concentrators, access lists, security groups, and all kinds of cool stuff. So yes, that's why I call it a virtual private data center. A single cloud is always a single point of failure, yes, no matter what you do. AV, yes, 2 is 1 and 1 is none. Absolutely, we say that in the tactical community, but when it comes to high availability systems, absolutely. How does routing work in hybrid cloud or multi-cloud? So Legit, the same way it does in every other environment via destination IP address. So you've got BGP, you're exchanging routing information. Once you get a route, the router looks in its routing table and it determines the best path, meaning the longest prefix works. If it's BGP, if the next hop is not available, don't put it in the routing table. Prefer the path with the largest weight, prefer the path with the largest locus preference, prefer the path with the shortest AS path, prefer the path with the lowest multi-exit discriminator, prefer the path with the lowest origin code. So the same way all IP networking works via destination IP address, and the same way BGP works, and it has for the last 30 years, that's the same way routing is done in between cloud providers. Your routers, they run a routing protocol, and that's how they do these things. Devendra Singh. Wow, what a cool name. A last name that means lion, and the first person that actually hired me was a Punjabi guy named Devendra, and he gave me my break when I left medicine and went into architecture 25 years ago. So love that name. What services do you decide to share between clouds? Whatever ones you want. You can run your same web server on 2 clouds. You can run a database across 2 clouds and synchronize it, whatever you want. Do you duplicate the exact structure with various cloud providers with the multi-cloud architecture? Nina, generally speaking, well, there's 2 ways you could do it. So let's say you wanted to run a machine learning application. And now there's 2 ways people do multi-cloud. Now, there's multi-cloud for high availability and there's multi-cloud for optimization. Nina, first I'll talk about multi-cloud for optimization. So let's say you've got a web application and you decided to put the same web on AWS and Azure. Now, when you're doing this, you're not going to be able to use like AWS WAF and the Azure silly homemade firewall either. You're going to have to use a firewall that's going to work on both, like an enterprise grade firewall. So kind of keep that. So understand that. And so we could have, for example, a website that is duplicated in 2 cloud providers. And that way, if AWS fails, Azure fails. But what else could we do? We could say that we're going to stick our website in AWS and Azure, and Google is the world's #1 algorithm maker. They run the #1 search engine algorithm, the #2 search engine algorithm, and they're probably the best at machine learning. So what if we deployed our application in AWS and Azure and sent all the machine learning to Google? Lots of organizations do that as well. So we can choose clouds based upon being better, like Google probably has the best machine learning libraries, or we can just use clouds like I usually do as a data center. They're all identical. Stick whatever virtual machine you want in a virtual machine and you're good to go. When you have a multi-cloud, is the data managed and handled by all 3 providers, or is one primary, or others backup? After-P, it's all up to you. After-P, I could have my own data center, and I could have my storage in my data center and have a direct connection to 3 clouds, and all 3 clouds could actually use the storage that's located in my data center. Or I could keep it all in a single cloud and share it. That's the way I want to do it. So it goes either way. That's up to you and where you want to put it. From a cost, latency, and performance perspective, well, they're all different. From a latency perspective, the cloud is the worst thing you could ever do. And if latency is your goal, don't go to the cloud, period. Cloud computing has horrible disk performance. Cloud computing has horrible network performance. So if latency is your goal, don't use the cloud at all. Now, if latency matters to you, you can use hybrid, meaning you can stick your low latency things in your data center and stick your non-latency sensitive things in the cloud. And that's generally the smart thing to do. From a cost and performance perspective, you're going to have to analyze it on a case-by-case basis. So Asim, I'll give you an example. I run an OpenStack cloud for my company, and my students use it all the time. I priced out the cloud on AWS. They wanted $11,000 per month. Now, I bought the servers for $10,000 one time, and I will get 3 years. So AWS wanted $380,000, and I paid $10,000. Now, why did it work? Well, I had all the firewalls and networking gear. I didn't need to hire a $250,000 CCIE because I am one, and I was able to build it simply and beautifully on my own. Now, if I needed to hire a CCIE, poof, that would have cost me $250,000 right there, and that would have made me think that AWS was cheaper. And if I didn't have my firewalls and switches and routers, yes, it would have been cheaper on AWS. It would have been more agile, better, faster, and cheaper. But because I had that gear and the specialty, it was 30 times cheaper to run it off the cloud versus on the cloud. So it's always going to be based upon the use case that's going to make it determine what you need to do. Chris, you can go to the next one. So realistically speaking, and that's why we have the Cloud Architect Career Development Program, is when it comes to these architectural decisions, I want to let you know that there is always going to be a trade-off. Whatever we do here costs something. There is no free. So when you reduce latency, guess what? You change things. If you use longer time to live to improve scalability, guess what? We're going to run into the same thing. So there is no such thing as which is better. There is no architecture. We're not engineering where we can say this is more powerful than this. There is never a this is better. There's what is the best case for what. What determines what's the best case? The business requirements. Are they to improve performance, to cut costs, to improve collaboration, to fix defects? The business drives the technology. If you're a bank and a nanosecond of latency is $1 billion a year of you to competitive advantage, you will build around nanosecond latency. And if it costs you a quarter of $1 billion to get to a nanosecond of latency, but a nanosecond of latency gives you $1 billion of earnings, you'll spend a quarter of $1 billion on it. Now, a hospital won't spend any money reducing latency because it's irrelevant to them. If a nurse gives a drug a second later, who cares? Not a billionth of a second later or a millionth of a second later, it doesn't matter. So it matters. Now, a hospital, if the systems go down, people die. So do we think we should use a single cloud for that? Of course not. But maybe if I had a website that was mycatcindy.com, I should stick it in a single cloud. Do I need to use 4 clouds to protect a website of my cat Cindy eating rats, mice, and birds? Of course not. So, it's all a matter of what are we building for? What are we trying to protect? And that's why, that's what we do in our career development program, because these are the decisions architects have. Unfortunately, they're far out of, in a multi-cloud architecture, are you using multi-regions of both providers? You could. It's up to you. So if I had half my users in India and half my users in the US, I'd be using 2 regions. If all my users were US-based, I'd probably use only US-based regions with Azure and only US-based regions with AWS. When both AWS and Azure is hacked, can you take them both down? So here's the thing. If we build our data centers right, and maybe, just maybe towards the end of the week, I will show you how you build a multi-cloud architecture and lock it down for security. And AWS gets hacked, you can make it so that if AWS gets hacked, it doesn't affect your data center. And if Azure gets hacked, it doesn't affect your data center. And you can make it that if a hack comes in from AWS through you to Azure, that doesn't happen. So yeah, we've got all kinds of cool policies we can do. In a multi-cloud, again, it's what do you want to do? So you can have a direct connection to both clouds. You could have the clouds talk to each other and only connect to one. But if you only connect to one and that connection goes down, you can't reach either cloud. So most people would connect to both clouds. But again, these are architectural design considerations. That's why it's not engineering. So Reynolds, I'm going to ask you this question. We now have one cloud, multiple regions. And for some reason, the network gets hacked. All the regions are dead. The control plane that orchestrates the whole cloud goes down. All the regions are dead. So you can never, never, never have the same benefits on a single cloud provider as you could multi-cloud. Never, never, never. And Renaud, when AWS had a power failure in the middle of North Carolina, why did it take the whole globe down? And when AWS had an impaired network in one part of the US, why did it take the whole global network down for hours? Why was not AWS, Azure, or Google able to deliver 99.99% availability to their customers last year, no matter how many regions and availability zones anybody used? Why? Because it's all the single cloud, and as much as you want to, AWS wants to pretend it's not, it's a single network, and if the network goes down, everything goes down. And we're going to go back to the lessons, but I want to make sure that you download the lab registration videos and make sure you tune into our show tonight. And that's why when we have these discussions in our YouTube videos and we created a course, it's because the job of an architect is to know what to use, when to use it, how to use it, and why to use it. And it's never, ever, ever about what's better. It's about what's best for this situation. So if I'm an architect and I meet with 10 clients, 10 clients are going to get 10 different architectures based on their 10 different business problems. So please make sure you join the show tonight. We'll have me and Alonzo. We'll probably, and a special guest, Eva, who is fantastic. She'll light up the room. So join us tonight. And start following and subscribing if you're not. And that's what we always talk about, architectural considerations. Okay, so let's go back to the content for now. And actually, before we start, if all of you can type #CloudHired. And it lets you know Chris from my team is looking at some of these questions. And if certain questions keep coming up again and again and again and again and again, guess what? We'll make you a YouTube video to get you all cloud hired. So you can all type #CloudHired in the chat box. We know you're here. We know you're excited. We know you're working to learn, and we love that. And while you're at it, if you can a like, a comment, a subscribe, and tell a friend. We always appreciate likes, comments, and people that subscribe. So let's get back to what we were talking about here. Training content-wise. Let's talk about connections to the cloud. So I want you to think about it this way. If you put all your stuff on the cloud, you better be able to reach it. Because if it's here and you've got no network, it's like it doesn't exist. So imagine you've got a giant lake and you've got a house. And if you don't have the lake connecting to your house, you've got no water, which means no water drinking, no showering, no dishwashing. So it's like the same thing. The cloud is where we're putting all our stuff. So if we can't reach that stuff, it's no good. So how do we connect to the cloud? Now, we're going to give you a couple of options. Now, ultimately speaking, there are a lot of options, but for this, we're going to talk about two. And we will talk about VPN technologies, and we will talk at least IPsec VPNs, and we will also talk about private lines or direct connections. So we'll begin by talking about VPN. So what is a VPN? A VPN, quite frankly, is simply a means to secure private network connectivity over a public something. Public something. Now, what is that something? That's another story. A VPN enables you to create a private network inside of a public something. So there's lots of VPN technologies. There's IPsec tunnels, L2TP tunnels, SSL VPNs, MPLS BGP VPNs. But today, we're going to talk about IPsec VPNs. So why not just send the data over the internet? Okay, here we got, I got Chow over there. Why don't I send Chow my banking information over the public internet? Well, a couple of reasons. The public internet is not secure. So now I want to send Chow over there with a blue wrench, some kind of secret thing. I send it over to the internet, and guess what? The whole world sees it. So Chow and I didn't have private communication. I can't do that. Now, here's the next thing. If I want to send Chow private IP addresses over the internet, can I do that on the public internet? Absolutely not, because I can't use anything from the RFC 1918 address space. Anything in the 10.x/8 range, anything in the 172.16/12 range, and I can't use anything in the 192.168/16 range because it's private addresses. But in a private network, I can. So that's what we're really talking about. And then security. So we can't just send our data over the internet, or it'll be read, it will be hacked. So we have to find a way to actually take data over the internet and make it secure. And that's what we're doing with the VPN. Effectively, what we're doing is we're taking two environments and we're creating a tunnel through the internet to make the appearance of a wire over something that doesn't exist. So let's talk about VPNs and what they're built on. We're really talking about IPsec VPNs. And what happens, there's a protocol called Internet Protocol Security. And Internet Protocol Security is a protocol used to create a secure tunnel across the internet. And what happens is IPsec it uses something called encryption. So if Chow and I want to talk to each other across the public internet, and if I say, how are you, Chow? And she says, I'm doing great, Mike. How are you? The whole internet can see what I said to her. Now, if Chow spoke another language and not Vietnamese, because lots of people speak Vietnamese as another language, but if Chow and I had our own language that only she spoke and I spoke, We could talk to each other on the public internet and nobody else would understand. But I can't use English because people speak English. We can't go to my go-to, which is Greek. We can't go to Vietnamese for ciao because people speak that. But if we had our own private little language, we'd be talking to each other and nobody would know. So that's what encryption does. Encryption, which is part of IPsec, enables me to make sure that when Chow and I talk, nobody gets any part of the conversation. So that's the first thing, Chow. And thank you so much for being here, Chow. I love talking to you. You were a fantastic student, and that's why we're thrilled to have you in our company. But, there's that. So now, let's say I want to have a conversation with Chow. But what if Chow's not Chow? And what if I want to tell Chow stuff that's really important? But what if instead of it being Chow, it's a bad person called Joey? And what if I think I'm talking to Chow, but it's this evil guy, Joey, on the other end, and I'm giving all my secret information, not to Chow, who we love, but mean Joey, who wants to hurt me? Well, that would be a problem, right? So IPsec provides peer authentication. So we create a VPN. I identify that Chow is in fact Chow. Now, I then encrypt all the data so that we only speak our own language so nobody understands that. Now, the next thing that I do is I hash the data. So if I want to send Chow a message that says, meet me at this location at 2 p.m., and there's some evil person on the there that says, meet Mike at 2000 hours. Well, I'm expecting Chow to be there at 2 p.m. or 1400, and she's expecting me to be there at 2000. We've got a problem. Now, let's imagine in a banking state, I want to make a bill for $1,000 and somebody changes it to $1 million. Ooh, this is not a good thing. So there's that. So keep that in the back of your mind. Then, so that's called message integrity, and that occurs via hash. Now, would it be cool if I said something to Chow, and then after the fact, Chow couldn't say that I didn't say it to her? That's called non-repudiation. So IPsec, which is used to create your secure tunnels across the internet to send your information, does the following. It makes sure that your data is encrypted so nobody can see it. It makes sure you authenticate the end user so that Chow is Chow and not Joey, the bad guy. It makes sure that if I send Chow a message, the message didn't change. And afterwards, I can't even say I didn't send the message. IPsec was the blockchain prior to blockchain. So kind of keep it up and running. Like that. So let's talk about some VPN advantages and why organizations use VPNs. Well, organizations use VPNs for the following reasons. Private lines are somewhat expensive. Now, private lines, which are wonderful, and we'll talk about them next, take time to set up. Hey, AT&T, I need you to build me a location between New York and London. 6 weeks later, I've got it. It's great, right? Perfect. But what if I wanted to do it in seconds? What if Chow's over there in Vietnam visiting her family member right now, and I want to create a connection to Chow, but Chow has internet access? With a VPN, we can configure our routers, and 3 minutes later, we're talking to each other in a secure encrypted environment. Because internet access is ubiquitous. It's everywhere. Now, who else is a blue wrench on this call? Okay, so I've got Chow that has a blue wrench. I think I saw Abigail with a blue wrench. So now, I want to create a connection to Chris with a blue wrench, Abigail with a blue wrench, and Chow with a blue wrench. Guess what? They're all connected to the internet. I can create a point-to-multipoint tunnel where we can all talk to each other. So that's what's so cool about VPNs. They're so fast and simple to set up. But what's not good about VPNs? Well, VPNs use what? Internet performance. And is internet performance guaranteed? No. Your internet service provider has no guarantees to deliver your data to anybody. So here's the thing on the VPN. You don't know if your data is even going to ever get through. Now, if any of you want to, just for fun, open a command prompt on your computer. And if you're on a Unix terminal or a Windows terminal, I don't care. If you're on a Linux terminal or a Mac, and you open a terminal window, type ping www.cisco.com, and guess what you're going to see? The latencies of each packet are going to get there, and you're not going to lose every packet. And then while you're at it, If you're on a Windows machine, do ping -T and you're still going to see that. But the key is we don't know what the throughput is going to be, and we don't know what the latency is on a VPN ever. So for that reason, VPNs are not good if you need guaranteed performance. If you need guaranteed latency, they're not there. If you've got real-time applications such as voice or video, you're probably not using a VPN either. VPNs are good because they are fast and they are cheap, but the performance is not guaranteed. So keep that in the back of your mind. Now, when you're connecting to AWS, you can use a VPN. Now, there's lots of ways you can do this. We're going to right now talk about the AWS way that you do it. And this is considered to be a site-to-site VPN. The way this works is both sides are going to be communicating with each other. And what will happen is you'll create an endpoint on one side and an endpoint on another side. And what they'll do is they'll encapsulate the packets with an IPsec header and put them into a tunnel so that inside in the tunnel, they can't be seen. Now, when the tunnel gets set up, these guys exchange keys. They do something with this Internet Key Exchange Security Association. So when I go exchange keys with Chow, what algorithm are we going to work with today? What's the encryption type, etc.? We set that up and we agree on the terms. Now, with AWS, when you configure a VPN, when it comes to networking, you can't reach anything if you don't have a route to it. So you can use static routes to route your traffic, and when we get to that section, we'll talk a little bit more about that. Or you could use BGP here. And see, there you go. We looked at a seam, and you can see that he's got one packet that took 126 milliseconds. The next one is 59, and the next one was 20. That's not a good thing. That's called jitter or variations in latency. Now, if he had a direct connection to AWS, that might be 3 milliseconds, and it would be 3 milliseconds every single time. So that's why the downside of VPNs. Now, here's where I'm going to give you the reality, and so you know what to do to work. And then I'm going to tell you the reality for the exam. There's lots of reasons we can't do these kinds of things on Zoom, and that we have to use a big massive media like YouTube. We use Zoom for our courses because we have a small number of students there, and we can have lots of people talking all at the same time. It's wonderful, but these are the kind of big medias that we must do on a platform like this that's designed for mass scale. And we especially want people to be able to watch this for the next month, 2 or 3, so they can get free access to training, and that's why we did it here on YouTube, to really help the community. So when we're dealing with these, when we connect to an AWS gateway, so normally speaking, you got a router who connects to a router. Now, when you connect to the AWS world, you're connecting to a virtual router. Now, when we're dealing with a physical router, it can go down. But when we're dealing with the virtual router, it can't go down. So, according to AWS, if you connect to them, it is a single high availability system. And here's why. When you connect to AWS, and I'll show you, what happens is as follows. You've got a router in your data center, which you can see on the right side of this. When you connect to the AWS VPN concentrator on the other end, it automatically sets up 2 tunnels. One tunnel to availability zone 1, one tunnel to availability zone 2. So AWS will tell you this is a high availability solution, good to go. Here's the problem with that attitude and that solution. If this router on your end dies, your whole network is down and both connections to both VPCs go down. So you can't say we've got a single of anything and we're available, because this will go down and it'll go down every single time. So we can't do this. So what do you really need to do is let's architecturally map it out. You've got your premises environment. You got a premises here. Now, I would tell you use a single cloud is insanity, and I would never do it. But even if we did, here's the thing. If you only have a single router over here, I wish I could take that phone call from Nigeria right now, but can't. So if, for example, we could take, we put a router here, and then we connect to the AWS environment, and they say, hey, guess what? It's really a virtual router, so it's like the equivalent of 2 over here, which is what they're saying. And to some degree, they're part right. But you got the router here, and this is what it does. So when you set up your thing, it basically gives you a connection from here to here and here to here. Great, right? Now the router goes. You don't have any connections. That's not good. Or the physical connection where these logical connections goes down. And guess what? Then you lose them both. So as you can see, this is about the worst idea you could possibly do. Just because they're available doesn't mean you are. So when you're using any of these things, you need to back up. You need 2 routers on your end and 2 connections. So if this one goes down, then you've got this one. Now, because we're not using one because one is a single point of failure, now we've got a logical connection from both. So now we've got high availability because what happens is each connection builds 2. Now, if this router goes away, no big deal. We're still up and around. Now, if this router goes away, no big deal. We're still around. Now, guess what? If this router goes away and this link goes away too, does it matter? No. So that's why we can't allow anybody to say, hey, guess what? All kinds of exciting. You don't need to worry about this because we're high available, but that doesn't mean both sides are. So that's why we're talking about what we're talking about. So now, how do we improve VPN availability? Well, we use 2 routers on it. How about using 2 internet connections? So if one of our internet connections fails, we've got the second one. So when we need high performance VPNs, guess what? We must use at least 2 internet service providers. Because if you're backed up on AT&T and AT&T goes down, you lose it. So you use one on AT&T and one on Verizon or CenturyLink or NTT. I don't care. Pick a good one, but never use one. So in the tactical world, we say 2 is 1 and 1 is none. In the SWAT teams, they say 1 is none, 2 is 1, and 3 is better than 2. So whatever the case is, never, ever, ever have a single point of failure. Now, how do we set up these VPNs? Well, pretty easy. We determine which virtual gateway we're going to connect to. We pick a method of routing, static or dynamic. Let me tell you, dynamic routing is simple. Static routing, and here's the difference between a static route versus a dynamic route. A dynamic route is your GPS. You get in your car and you say, I want to go to Chow's house. You get in your car and you drive. The road's blocked, your GPS reroutes you and you get to Chow's house. It's really great. That's dynamic routing. Here's static routing. I build a map. I print out directions to Chow's house. Now, as soon as I'm on the way to Chow's house, I'm driving to Chow, life's good, right? No, there's a roadblock. I don't have a map in my car and I don't know how to reroute. That's static routing. So I don't like using static routing when there's multiple ingress and egress points because I like things to be self-healing, but just know that you can do that. Now, what'll happen is as follows. For the cloud engineers that are doing their configuration, what'll happen is the AWS cloud will spit out a configuration they can cut and paste in the router. Now, the reality is for those of us that are architects, cloud architects, we're going to design the routing. We're going to design the BBTP architecture, and then the cloud engineers will configure it for us, or ideally the cloud network engineer. But it's not always going to work that way. So you can configure it on the management console. It'll spit out all the things, and then you can just cut and paste those configurations in there. Now, that's VPN technologies, VPNs, and that is basically setting up an encrypted tunnel across the internet. The next thing we're going to get to is a direct connection, and we love direct connections because this gives us good performance, high availability, and everything is super awesome. So direct connections are next, but before we do it, we're going to go for 10 minutes of questions on VPNs. So Chris, if you want to bring in some questions from the blue wrenches that they've aggregated and answered, then we'll go back to the content in 10 minutes. Okay, well, if we see any questions that pop up, we'll answer a few. Otherwise, we'll start talking about direct connections. Chris Charles, realist. Is it not more secure to have two Verizon links from two different POPs instead of two provider? Okay. So, Christopher, we can never use two links from Verizon. Ever, ever, ever. So, but we also can't have two links that use the same local copper loop either. So, when I went into networking 20 some years ago, what did they say? Never use a single service provider. And whether you get that advice from Cisco, Juniper, or anybody big in networking, they will never let you do it. So you must use two separate providers, because if you use two links with AT&T and AT&T gets a cable cut, you're good to go. But when AT&T has a problem with their network, you lose everything. So if you have two links with Verizon, you run into a problem if Verizon has an outage. Now, Christopher Charles, years and years ago, when everything was a pure private line, it was a little less scary, even though it was still scary. But now, we're dealing with virtual wires, which are signaled over RSVP, signaled over MPLS-based networks. So with what we're dealing with now, it has to be definitely two discrete service providers. You can never use the same service provider. But what I'm also referring to is some buildings of AT&T and Verizon and CenturyLink all going through the same copper conduit. That's no good, because that way, if the copper conduit gets cut, all your service providers get cut. So what you need to do is make sure you've got service providers across multiple organizations, multiple conduits, and you'll be good to go. Aladra, do you add routes for the cloud provider on your routers on your own? Oh, so yes. So here's the thing that goes on. When it comes to reaching things, the subnets need to be able to reach you, and you need to be able to reach them. So you will have to advertise the routes to the cloud that you want to be able to reach back to your systems. And you will need a route to the cloud systems, otherwise you won't be doing it. So you'll be doing some routing on the cloud side and some routing on the data center side, absolutely. And you have to add the routes. That's under ARC. Difference between non-repudiation and peer authentication. Miss Lam and gentlemen, let's say you're in a pharmacy, and let's say you're actually a pharmacist, and I call in and say, Miss Lam and gentlemen, I have a patient that's depressed. I'm going to prescribe trazodone 150 milligrams, dispense 30, and for the SIG, I say take one PO-QHS, which means every night, and I give 11 refills, and I sign the prescription and give it to my patient. Now, after I write that prescription and I turn that prescription in the pharmacy, that pharmacy photocopies that prescription. Now, after the fact, I can't say that I didn't write a prescription for 150 milligrams of trazodone, dispense 30, take one PO before bed. That's non-repudiation. I can't say that I didn't do it. That's non-repudiation. Now, peer authentication. Let's pretend, Miss Lam and Jamin, you're a pharmacist today. And I go into the pharmacist and I say, hi, Miss Lam and Jamin. I am Michael Gibbs, and I am here to pick up my prescription. And you say, can I see your driver's license? That is authentication or peer authentication. You authenticated me. So I hope I answered you. Non-repudiation means you can't say you didn't say it, and peer authentication is doing this. VPN connections are almost exclusively encrypted via IPsec tunnels. Absolutely. And they must be. Is it possible for the prem router to fail? Absolutely. It happens all the time. And that's why I said it didn't matter if the AWS was available. You needed two on your own, because just because theirs wouldn't go down doesn't mean yours wouldn't. And yes. What is the difference between a route and a routing table? That's a good question. A route says a route is just a path to a destination. So if I have one path, one route to get to Chow's house, I'm good. But now I want to go to Chow, I want to go to Afri P, I want to go to Karen, I want to go to Douglas, and I want to go to Abigail, and then Chris. If I were to build like a spreadsheet, for example, that it listed to get to Chris's house, go here. To go to Chow's house, go here. To get to Afri P's house, go here. Guess what? That's a routing table, which is a list of routes. Practical difference between static and dynamic routing? Very simple. Static routing. Make a left on this corner, make a right on this corner, make a left on this corner, make a right on this corner. That's standard routing. You know it, you print out directions. Dynamic routing. Well, make a right, make a left. Wait, the road's blocked. Reroute. Go somewhere else, go somewhere else. And that's dynamic routing. It automatically calculates routes when they exist. It adds them. When they go away, they remove them. And that way, things are there. So imagine a GPS in your car. That's dynamic routing. Cecile, why not just set up direct connections and omit VPNs? Many customers won't use VPNs at all, and they'll only use direct connections based upon their performance. And we'll talk about that soon. So in short, are virtual routers a big no-no? It's not that the virtual routers are a problem at all. It's just that our physical routers that connect to the virtual routers are not high availability. So it doesn't matter if they're high availability. We still need two on our end, because otherwise it's like, great, this half's high available and this half isn't. When this half fails, you lose everything. Well, Tushar, I don't know what you mean by bandwidth constraints in the customer premise, because if you're setting up a direct connection, it's a new wire. And if you want to do it over a VPN, you can get a new internet connection. So it's not like currently exists. Remember, you're the architect. You're going to design it based on what it needs to be. So you determine what it needs to be. Now, we architects don't build it. That's for the engineers. We architects design it, but we architects better know what to design. So based upon what we need. So if we need a direct connection, we use it. If we need a VPN, we use that. Best suitable use case, an example of a scenario to select a VPN. You've got something, latency doesn't matter, time doesn't matter, and performance of your network doesn't matter, then you use a VPN. And you're extremely cheap. And you don't use a lot of networking. That's when you use a VPN. Regarding VPN, can the company create their own, or you have to choose one? Well, you could create your own AfriPay. So instead of dealing with any of the cloud providers' VPN nonsense, period, we could just stick a Cisco firewall there that also has VPN concentrators, and we could VPN in. It would auto VPN, add us to BGP, and do the routing dynamically, and not have to deal with any of these AWS networking services at all. So, there's lots of ways we create VPNs. Virtual routers don't go down. Okay, so why not? That's a logical device. Logical devices don't break. So it just can't go down. So if I put a loopback address on a Cisco router, it doesn't go down. There's nothing physical to go wrong. There's nothing like a keep alive that needs to be sent for it to stay up. Non-physical devices, if you tell them to stay out, just don't go down. It's because it's not real. The only way it could go down is if their entire systems were down. So if a data center lost power. Now, I got to tell you, I've only seen one data center in 25 years lose power, and that was an AWS data center. And the reason I've never seen a data center have a power failure is all data centers use two power companies. They typically have multiple generators. They typically have backup generators, and they typically have backup power. So the only data center that I've ever heard of in 25 years that didn't exist in somebody's closet as a hobbyist was the AWS one, if that in fact actually did occur. So logical devices don't go down because they don't exist. There's nothing, they're not real. So would you say using static connection is not a good idea? So I don't know if you're talking about connections or routes, but here's when a static route is good. If there's only one way for me to reach Chow, only one way, and I can't reach her via any way, then a static route is good. But if I wanted to reach Chow, and there's 40 or 50 alternative paths to reach to her, if this one is blocked, take another one, take another one, take another one. I use the dynamic routing. So think about it this way: a dynamic routing protocol that uses an algorithm to exchange reachability. I've got 3 wires, 1 wire, 2 wires, 3 wires, 4 wires. This is like reality in a lot of times in your network. You've got all these connections. Now, if I'd like to go from this connection to this connection or this connection, if something fails, I need a dynamic router, because otherwise, this static route is only good for this. And that's why we want the self-healing capabilities. Tyrone over there in South Africa. Which one is more cost effective? Well, it depends. Generally speaking, in the real world, outside the cloud providers, direct connections or private lines are always more expensive than VPNs. But in the cloud, it's not like that, and here's why. Here's a normal connection. I get a direct connection from my house to Chow's house. I pay $5,000 a month for it, and it's there. Now, if I send 10 gigs on that direct connection, or send no data, I pay the same $5,000 a month to send the data to Chow. That works in the US. That's the way networking and WAN connections work in the US. Now with AWS, I pay for the connection. I also pay a daily fee that the connection exists, and I actually pay to use the connection. So if I'm using a VPN, which offers poor performance, but I'm using it a lot on the AWS cloud, using that poor performing VPN often becomes more expensive than the direct connection because the usage rates on the direct connection are lower because they assume you'll use the direct connection if it matters in a VPN if you don't care. So keep that in the back of your mind. But the answer is it's going to depend by the type of traffic patterns you have. And when it comes to this, there is never an easy yes or no. You will always have to look at what is the business goals. What business problem are you solving? What does the business need? What does the application need to improve the business? It's business. And then from your business acumen knowledge, then you can go back and solve it with technology. And that's why this is not a career, at least cloud architecture, of just tech. It's 50% business, 50% tech, because these are great questions, and I'm going to keep answering them as we go through them. So now let's talk about private connecting and private lines, or the equivalent of them. And that's really what we're talking about. When we're talking about these private lines, we're going to be calling something called a direct connection. Now, a direct connection is not exactly a private line. We're going to get in there pretty deep and talk about how they work. But I just want to really understand, make you guys understand everything. So, normally speaking, you can think of a direct connection or a private line or a direct interconnect or an Azure Express route as a wire, a logical wire between two locations. That's all it is. And why would you use this? Well, this wire always has the same speed. So if this is a 10 gig wire, it's always 10 gigs. If it's 2 milliseconds to Chow's house, it is 2 milliseconds today, tomorrow, next week, next month, because that's how long it takes the speed of light for the photons to traverse the wire in my fiber optic cables. So now that you know. So direct connection, guaranteed bandwidth, guaranteed latency, and the most availability because it's guaranteed. And of course, I can get these now in any kind of Ethernet WAN speed. 1 gig, 10 gig, and even 100 gig, which I think you're going to see a lot faster than that coming soon. So while I call it a logical wire, in reality, it is not. There's several stops along the way. Now, whenever we're dealing with WAN connections and Ethernet WANs, what we have to remember is they are fiber optic Ethernet connections. So when we deal with fiber optics, we've got two kinds. We've got multi-mode fiber and single-mode fiber. Multi-mode fiber, short distances inside your data center. Single-mode fiber, data center to cloud, data center to someplace that's 2 miles away, 3 miles away. So when we're dealing with this, we are dealing with single mode fiber. Everybody remember it. It's a test question. Single mode fiber. And I'm going to walk through first showing you what it logically looks like, and then I'm going to show you what it physically looks like. So from a logical perspective, here's what we're talking about. We got our organization, we've got our direct connection, private line, direct interconnect on Google, Express route on Azure, same thing. What we're actually dealing with is over here. And that's what we're realistically talking about. It's what it looks like to us. But in reality, that's not what's going on at all. In reality, what's going on is here. We take our on-premise environment and we are buying a WAN connection to a direct connection location, otherwise known by the rest of the world as a point of presence. So what happens? We get a connection to here. Now in the direct connection location, we have our own routers or switches, our stuff. So we're buying a connection from our router to our router, our router to our router. Now, just because we get a connection from our router to our router doesn't mean we can reach AWS. So what happens is we get a connection from our router to our router, and then we have the company run a cable between our router to the AWS switch. Now that connection is called a cross connect. So I connect to me, and then somebody else connects me to AWS, and now I'm riding on the AWS network. So kind of keep that in the back of your mind. What it really is we're buying a connection to us, and then we get a cable called a cross connect, which brings us back and our traffic gets back hauled. So how does this work? Well, it starts with a fiber optic connection from your router to the AWS Direct Connect Location Center. Now the router is going to need a fiber optic port, and it's going to need an optic. So what happens? Do I have any sitting right next to me? Not right now. I usually have a couple switches sitting next to me. There's a port where you stick in an optic which has lasers in it. So the two kinds overall that we're going to use are single mode fiber, 1000 base LX, 1000 base LX, or for 10 G base dash LR. So 1000 base dash LX or 10 G base LR. I'm going to say it again. The spec that you will use for 1 gig is 1000 base dash LX. The spec that you will use for 10 gig is 10 G base dash LR. It's a test question. These are the fiber optic specifications that you're going to use. Now, if you've ever worked with fiber optic connections before, you understand that there's two lasers. There is a send laser and a transmit laser. So there's two sides of the connection. Now, if the send laser is up and the receive laser is down, unfortunately, not always routing protocols can detect that it went down because they can only see one side of the connection is left. So when you're connecting using fiber optic connections, the good news with AWS is they do support bilateral link forwarding detection, which if either one of these links goes down, it will shut both links so you can use the backup link. Hope that makes sense. So kind of keeping that in the back of your mind. Now you know what we're dealing with. So that's called bidirectional forwarding detection. It's going to remove a link, which is really great. Now, when we send things to AWS, we are sending them a VLAN tag. And really all that's going on is as follows. We're only sending them the VLAN for one reason. And here's the reason. So in this particular environment, let's say we've got us. I'm going to draw it out for you so I can explain it to you. So let's say we've got us. Now what we do over here is, now in this direct connection location, call this direct connection location. So really, and let's try to take the blue out of this so I can really show you what's going on. So hold on. Okay, let's turn this into a cool color that we can look at it. Bear with me for a second. I'm not Mr. I'm definitely not Mr. Software and never have been. Okay, so I don't know why I can't seem to change the color, but oh well. So let's not worry about that for right now. So let's say we've got this device. Now what happens is our device is going to plug into another one of our devices. So what we're really buying is this connection, which is from here to here. But now, do you think we're the only people that are connecting to AWS in this direct location center? No. So what's going to happen is AWS is going to have a switch here. and you're going to plug into this switch, and another customer is going to plug into this switch, and another customer is going to plug into this switch, and another customer is going to plug into this switch. Then let's say AWS has a couple of 100 gig links over here. So let's say they've got a couple of big links, big fat 100 gig pipes. They've got like 2 or 3 of them, and they're all bundled together in a link aggregation group. So together we've got a 400 gig link. Now, how do we keep customer A's traffic, customer B's traffic, customer C's traffic, and customers D traffic all separated on this same line? Well, we could do a couple things. We could create a layer 3 routing environment where we could create virtual routing and forwarding instances. And for the CCIEs like me with 25 years experience, we used to do this with the BGP VPN. But now imagine how simple this can be. So you've got customer A's traffic on the wire, and it's on VLAN 10. So VLAN 10 can't be seen by anybody else. And now let's say you've got customer other's traffic. This customer's traffic is coming across this wire on VLAN 20. And this customer's traffic is coming in across the wire on VLAN 30. So what happens is AWS is going to ask you to send them a VLAN. Now, we're still going to be connecting them to layer 3. We're still going to be doing BGP with a dynamic route, but we're going to send them a VLAN. And by doing this, AWS can create a layer 2 VPN for themselves to use to separate all their customers' traffic. So that's really what's going on. They're creating a VPN for you to segregate yours traffic. And that way, Al, who's over the US, Mufaz is over there in Nigeria, Rohan is in the US, and Ali, I believe, is in the US, and Tyrone, I know, is in South Africa right now. And that way they can all share the wire, but be separated from each other. And that's why we're sending them VLANs. A couple more things to talk about with regards to this. So when you want to make this connection, and this connection is really critical, when you want to go from your device to the AWS device, you can easily get a connection to connect to you, but you can't connect to anybody else without permission. So what's going on is as follows. When you want to set up your direct connection, you have to request something called a letter of authorization. And here's what happens. In order to receive a letter of authorization, and all the letter of authorization says is the service provider is enabled to connect your router to the AWS network via cable. The letter of authorization says the provider can do that. So that's how you get admission to the AWS network. So what happens is you have to request a letter of authorization to connect to AWS. And you can do this by going to the management console, the API, or the CLI. And when you fill out your application, if your application is complete, what's going to happen is AWS will provision the switch port at the Direct Connect location for you to plug into. Then you'll get approved. You'll download the letter of authorization, and then the provider will establish the cross connect. And then you're on to their network. So there's that. Now, when we're dealing with direct connections, we have the concept of public and private interfaces. So what does that mean? So if you want to connect to your private stuff in your VPC, guess what? You use a private interface. Private interface, private stuff. But what if you want to connect to some of these public services? DynamoDB, and there's a million and one reasons I would never use it, but if you wanted to use it, for example. SQS, and I can think of a million and one reasons you would never use it in a multi-cloud architecture. But again, if you want to connect to these public endpoints, you're going to use the AWS public virtual interfaces. And yes, as we get through, I will talk about services such as DynamoDB, which are perfectly good in exam, but usually not so good in real life deployments. And I'll tell you why and where, so you guys actually understand it. Because if you start talking about certain things from certifications on an interview, they'll send you home, because there's what we do in real life and what we do in certification. They're different. So we'll try and highlight those things as we go through the week, since I want you to all be successful and get cloud hired. So Public interfaces are used to connect to these things. Now, when we connect to AWS, we have to understand that AWS will not re-advertise URLs out, which I want you to understand this. AWS will not re-advertise URLs out, which, good news, you don't become a transit autonomous system for internet traffic. Bad news, you don't have transitive routing unless you do certain things. So we'll talk about that later when the time becomes appropriate. And also understand that with AWS, you've got a very, 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 very minimal BGP implementation. In fact, you can't send more than 100 routes to AWS. And for those of you that are network architects like me, you know that is nothing. I routinely work in environments where there's 30,000 routes, part of an organization. And when you connect to the internet, you get about 800,000 routes from each service provider. So realize this is nothing. Now, why is it nothing? AWS has thousands and thousands of millions of customers. They can't take a billion routes from everybody, but keep that in the back of your mind. So what does this mean? It means your IP addressing scheme is going to have to be perfect. It means your route summarization is going to be perfect. Your IP addressing plan needs to be perfect, or you will be in all kinds of trouble. So keep that in the back of your mind. Now, what if you needed more bandwidth? So let's do some simple math together. Let's have a little bit of fun with it. So let's look at this. So now let's say we've got two environments. You got a switch over here. Let's say this is in our happy data center. Doesn't really matter where it's at. And let's say this is our WAN connection to the direct connect location.
Mike, we can't see your screen.
Oh, thank you. So let's say I've drawn two boxes over here. In box one, we've got a box that says switch. In box two, we have a direct connection location. Okay, so now let's put a gigabit Ethernet link between them. Everybody in the chat box, I've got a gigabit Ethernet direct connection. How much bandwidth do I have on a gigabit Ethernet link? I'll play the Jeopardy music. Do 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 bum 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 bum. Okay, everybody, how much data do I have between us with this 1 gig direct connection?
You better watch out, Mike. You might get a copyright against us.
Oh yeah, I can't do any. We gotta be careful with that stuff. Oh, and I wanted real official Jeopardy music. Okay, Danica, yes. With a gigabit connection, we get a gigabit. Brian, exactly. 1 gigabit connection, we get a gigabit. A gigabit, yes. Good job, Wally. Okay, now we get a gig, or no, we get a gig. Good. You guys get it. Oh, wait a second. What if I need 2 gigs? Do I have a problem? Yeah. Now, what if I want 2 gigs? What do I do? What do I do? Well, I got a couple options. Now, the easiest thing to do would be if I get another direct connect, another link. By nature, am I going to use both links? And if I just set up 2 standard direct connections and do nothing else, I'm going to have 1 link that's working and another link that's dead. Ugh, don't like that. Now, what if I could take these 2 links and make them look like a single link at the same time? And then, hey, you know, that's not enough. Now I need 3 gigs. Add a 3rd link. Oh, wait, I need 4 gigs. I want a 4 link and up and running. From a guy like me with BGP, it's simple to load share across all these 4 links. But for the average non-network architect, how do I share across these links? Well, I've got options. I can't get bigger than a gig until I go to 10. What if I bundle two links together? So this is a 1 gig link. This is 2 links that look like 1 big wire. Now I bundle them together and I've got 4. Oh, wait, I've got 1 wire now. 1 wire, single wire. Now, why do I love this single wire? What's so cool about a single wire? No spanning tree problems. No rapid things to do. I'm bundling. I'm inverse multiplexing 4 of them together as a single one. Wait, inverse multiplex, and now I've got 1 single wire to the rest of the world. No, one of these links goes away because it goes down. I still got 3 links in the bundle. Another link goes down. I got 3 more links in the bundle. So a link aggregation group, for those of you that are old networking people like me, port channel, ether channel, inverse multiplexers, point-to-point protocol where we aggregated multiple links together. It's the same thing back from our old ISDN days. We're aggregating single links, and that's what a link aggregation group is. So let's go through this. There are organizations that need very high-speed access to the cloud, something that can't be done by a single direct connection. Maybe you need 4 gigs versus 1 gig. Maybe you need 40 gigs versus 10 gigs. So the point is, a link aggregation group enables you to add speed, capacity, and redundancy. Now, when you do this, your links need to be the same speed. So if you're going to have a link aggregation group, you can't have a link from AT&T and a link from Verizon in it. They're not the same speed. All your links in the link aggregation group need to come from the same service provider. Oh. So now, let's say we've got critical internet performance and we need 40 gigs and we put 4 10-gig links in a link aggregation group across Verizon. What happens if Verizon fails, everyone? We've got nothing. So we've got 4 10-gig links in a bundle in a link aggregation group across Verizon. What do you think we need? We need 4 links across another service provider, such as AT&T, NTT, CenturyLink. We can't have a single provider because a single provider is a single point of failure. So that's what we have to do. So to tie this up, let's go over here, go back. I'll show you another logical example of a link aggregation group. And this, by the way, is how you build high availability, high performance networking. What you can see here is we've got a link aggregation group that goes to 1 direct connection location. And we've got another link aggregation group that goes to another direct location. So direct location center goes away. Who cares? You got another one. One of these links goes away. Doesn't matter. Your router that does this thing goes away. It doesn't matter. You got a spare going here. So 2 is 1, 2 is 1, 1 is none, and 3 is greater than 2. So now we've talked a lot about direct connections. We got into some ugly networking stuff. I love networking stuff. I've been dealing with networking since 1996. My CCIE number is 7417, and I love talking networking, but not everybody does. So let's do this. Let's take some questions. And please make sure tonight you come visit Alonzo and me and Eva. It's going to be a really fun show tonight. Banesh, I don't understand what you're still asking, but won't this still protect data? I don't understand. So if you rephrase it, I'd love to answer it for you. Difference between layer 2 MPLS VPN and layer 3. Okay, so when we're dealing with layer 2 VPNs over MPLS, really what we're doing is as follows. We've got our underlying IGP. It's either OSPF or intermediate systems to intermediate systems. And they're typically in a single area because we need all those LSAs. And then on top of that, we will have some RSVP signaling to signal tunnel bandwidth. They'll add a label or a tag distribution protocol to do MPLS routing. Now, at this point, we have 2 options. Option 1 is basically we create an Ethernet wire over this IP-based network. And that means signaling, tunneling the Ethernet signaling to keep alive, etc., and all the internet messages. That's a layer 2 VPN. So basically, we're creating a wire or a pseudo wire or multiple pseudo wires across an IP network. That is a layer 2 VPN. Now, layer 3 VPN is something that is totally different. I absolutely love layer 3 VPNs. I was one of the people that worked on some of the first layer 3 VPN MPLS networks, and I love them. So let's show you what this really is. And it's a little different. So if you want to look at an MPLS layer 3 based VPN, which is really a BGP based VPN, the first thing that we have to realize is what we create is this is one of the clouds I worked with about 20 years ago. This was specified in RFC 2447. So if any of you guys want to learn some really good internet routing stuff, and you read the RFC 2547, you'll get to read the spec for this. And what really happened is you've got your router over here. So this is your happy router, and we'll call this Mike's. And and I was going into there. Now let's say we've got Abigail. Abigail's got her own business running through this company, and we've got a router, and it's Abigail. Heck, while we're at it, Cal decided to start a cool business while she's at it. Cal decided to start a business making photos of my cat Cindy, who's the most beautiful cat in the world, and Abigail's cat, who's probably cuter than mine, but I'm still going to say mine is cuter because it's my cat. So now we've got Abigail, Chow, and we all have businesses all on the same cloud. So now we get plugged into this device, this router over here. And this is the provider edge router. Now what's going on is I'm on one subnet, and they're all on different subnets. So we're all on the same LAN. So we actually even have overlapping IP addresses, but that's neither here nor there. Now on this provider edge router, what has to happen is the router gets virtualized, and the router builds 3 routing tables, and it will have a routing table. It'll have, oops, let's not use this. It's going to have this routing table, and it's going to say routing. It's going to be our Mike, and inside it's going to have Mike's roots. So it's going to be 10.0.0.0. Let's say /8 interface. That's going to be the outgoing interface, G0. Now, at the same time, so it's going to have my routes, but it's going to be in a routing table called Mike. Now, when Abigail goes to this router, she's going to have a router that's going to be in a separate routing table. And her routing table is going to be called Abigail's. And Chow's router is going to be called, routing table is going to be Chow. So when we started with these MPLS-based layer 3 VPNs, and we basically took this router to have 3 or 4, 1,000 routers sitting inside of it, a virtual router. What's this feel like to you? So we take a server, we smack a hypervisor on it, and we create multiple virtual machines. That's the foundation for all cloud computing. EC2 instance, virtual machine, Azure virtual machine, Google Compute instance. Virtual router, huh? Basically, we took a router and its routing tables and we virtualized it, and we created separate things inside the same thing. Is this any different than any of the cloud computing we're doing now? And this is 25 years old. No, it's identical. We're taking a network and we are chopping it up to piece after piece after piece. That's exactly what we're creating in this situation. So layer 2, we created a wire. Layer 3, we created a virtual router, and we kept each other's routing tables separate from each other. So might have been a little bit techie over there. Let's get to the next question. Link aggregation groups, EVA, should always be through the same internet service provider. And here's why. There's different latency across different service providers, so they have to be all from the same one. So that means if you need one link aggregation group and they're all the same, you better have another one with different service providers. How exactly will you set up the link aggregation group? Your network engineers will know exactly how to configure it on the Cisco router. If you're a cloud architect, you will never configure anything because we're cloud architects or designers. If you are a cloud network engineer, you'll be doing it all the time, and you will definitely know how to do it. If the links within bundle with the same speed, you can't create them with the same speed, and that's the problem. A gigabit link is not a gigabit link because they all have different latencies. So you'll get out of order packets and all kinds of problems if you try to bundle them across different service providers. I don't know what you mean by re-advertising of routes. I know what you mean by advertising. So advertising a route, and hey, Brandon, happy to see you with the blue wrench, and thank you so much. Advertising means I tell a routing protocol that I have a route so it can tell everybody else who receives it. So, hey, Chow, to reach 10.0.0/8, take interface gigabit Ethernet 0/0. That would be in etc. That's going to be what's in her routing table. And she's going to, Cal wants me to be able to reach 10.1.0.1, 10.1.0.0/24. She has to advertise that in the routing table. Okay, I think we hit a lot of questions here. So the last question, can a virtual gateway die? No, it doesn't really exist. It's not real. Because it's not real, as long as any device in the AWS is up, open, that we're kind of that. So, okay, I'm sorry, we have 3 minutes of questions left. So let's do some more questions. So 1 or 2 more. When you have 4 1 gig links and make them a single leg, won't that limit the data to transfer? No, 1 + 2 + 3 = 4. So that's why you're getting 4 of them. And that's why there is no data transfer limit in a link aggregation group. It'll be the maximum aggregation by adding them together. So it'll be additive. 4 1 gig links = 4 gigs of throughput. The only way you'd ever have a data transfer limit on it is if you manually set up like a committed access rate on the routers. So no, there's not that problem. All right, Chris, I think I can do 1 more. Should there be 1 or 2 customer gateway on the premises side before the link aggregation group on the diagram? So, well, 1 is none, 2 is 1, and 3 is greater than 2. So you should never, ever, ever only have a single gateway. Now, each link aggregation group will have to be in a single router. So that means you should have 2 of them in 2 separate link aggregation groups. So let's get back to the content, but if you can all type #cloud hired, because that's what we do here. Everybody else is focused on certification. We're focused on getting everybody hired. So if you can hit the like button, subscribe, and hit the bell to be informed of new things, please let us know anything we can do to help you get to your career goals. So while we're doing that, we're going to start talking about storage. I love talking about storage. So we're going to talk about storage options in AWS. We're going to kick it off with, what is storage? Well, that's where you keep your stuff, your organization's data. And when we deal with storage, we're going to talk about 2 kinds of storage: volatile storage and non-volatile storage. So what's the difference? Volatile storage is stuff that's in RAM that goes away with reboot or instance termination. Non-volatile storage is persistent. It doesn't go away. So when you use your computer, you load your data into RAM. It's volatile storage. You reboot your computer and it's all lost. Store that information on your hard drive, reboot your computer, and it's there and it's waiting for you. So now you know the difference between volatile storage and non-volatile storage. So while we're at it, let's now talk about the following. Let's talk about the kinds of storage we're going to be working with. And we're going to start with block storage. Now, what is block storage? It is a type of storage area network technology, and you need to know that. So what I first need you to know is it is network storage. Network storage. Which means if the network is not there, guess what? You can't reach it. So network storage. So this is not physical storage. This is not local hard drive storage. This is network storage. Now, why do we use so much block storage on the cloud? Well, the reason we use block storage is as follows. Block storage is a type of storage area network. And the way this occurs is you've got your data and you break your data down into blocks. And, your hard drive does that too. But why is block storage so different and so unique? Now, where you can place these blocks can be anywhere in your environment as long as there's IP connectivity to it. So that means your storage could be anywhere in the data center or multiple data centers as long as you can reach it. So normally, you've got a server, you got storage inside that server, it's limited to that server. But with block storage, you can have your server here and your storage somewhere else and it still works. So that's what we're dealing with block storage. Now, block storage is low performance storage. We'll talk about that later. Block storage, regardless of what your cloud providers teach you on your exams, this is pathetically slow storage. And we will talk about how do you work around the storage in real life if you actually want to work. Because if you try to tell your customer block storage is fast, 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 unfortunately, you'll be fired and your replacement will thank you for the job opportunity. So we need to teach you what it is in reality, not just on a certification exam. So block storage is a type of storage area network where the blocks are placed wherever it's most efficient in the environment. So it decouples your servers and your storage, and it scales real well. So block storage is going to be used widely, and we will talk about when we use block storage soon. Block storage will be used like a local hard drive on your system, so keep that in the back of your mind. The next kind of storage we're going to talk about is object storage. Now, this is a slightly different type of storage. And object storage is another form of storage area network. Oh, wait, if you don't have network access, you can't use it. So kind of keep that in the back of your mind. So what happens with object storage is you have your data that's broken down into objects. Now, what's so cool about object storage is every object has an identifier. An identifier, which is pretty cool. Now, with each piece of data, as it's broken down into an object, there's something called metadata, which is added to that data. Now, metadata is in a description of that data. So what does that mean? I've got metadata on Chow. The metadata tells me that Chow was born in Vietnam. The metadata tells me that Chow is a rock solid, incredible cloud architect. The data says that Chow was super smart. She's got an IQ of 170. She's a super genius. And the data says all these other things. I can see that in the metadata. So now if I'm looking for a genius or a super rock solid person, I can search that metadata and Chow's name's going to come up. So when we're dealing with metadata, we can do a lot of it. And that's why people use object storage for its metadata. That metadata enables us to work and do some extraordinary things in the big data environment. But when we have to talk about object storage, we must understand this is not real storage. This is write once, read many times kind of storage. So if I want to distribute software, if I want to back up and archive something, this is the kind of storage, but I can't use this by a server as a regular hard drive because it's not real storage. Now, I've got one other problem with object storage. One major problem. Every time we put something on it and it gets modified by even 1,000,000%, it creates a new version by default. So imagine if we tried to use object storage as a hard drive. The hard drive has something called a swap file, which is virtual memory. You run out of physical DRAM and you use your hard drive as a paging file or a swap file. That changes every second of the day. So imagine a system that has a terabyte of RAM and it has a 1.5 terabyte swap file. If 15,000 times per second that swap file changes, you will have 15,000 times 1.5 terabytes every minute. And obviously that would be a problem. You'd fill up your storage area network. So object storage is good for things you write once and read many times. It's not normal storage and it can't be used by computers. Now, the last kind of storage we'll talk about before we actually get into the AWS storage type is file storage. Here's what file storage is: regular storage. Got a hard drive in your computer? Regular storage. Got a file server, which you map a network drive to? Regular storage. It's attached to the computer. It's on a network drive. This is file storage. What does it store the files as? Files. Not blocks, not objects, files. And it uses normal file systems such as NTFS, et cetera, et cetera. So now let's begin discussing AWS S3 or Amazon Simple Storage. And what is Amazon Simple Storage? It's object storage, just basic object storage on the AWS cloud. So object storage, if you're in Azure, guess what? It would be Microsoft Blob. If you're in Google, guess what? It's called cloud storage. And guess what? It's the same everywhere. So now you know it's object storage. AWS's brand is S3, but it's just their brand. And the AWS S3 is integrated into just so many AWS services. It's relatively high availability, meaning it's 99.99% available, which is pretty good. I mean, that means that's basically 52 minutes of downtime per year, and otherwise it's there, which is pretty solid. Now, what's amazing about this is the level of durability. So we're dealing with 11 nines durability, which means 99.99 all the way to 9 places of meaning durable, which means even if you can't access your information right now because something's down, it'll be there. And that 11 nines durability is amazing. It is pretty cool. So when we use S3, remember it's object storage. So what do we use it for? Well, we can back up our data really well with it. We can do static website hosting. We can distribute software, content, media. We can do some really cool disaster recovery planning with it and big data analytics. So why big data analytics? So normal storage is hierarchical. Make a folder, put a folder inside your folder, etc. Now, considering this, in this particular case, because it's got metadata and because object storage really is like a database. Basically, you've got this big flat environment and you've got a little bit of data and you've got a database planner that says to access this data, click here. So that metadata and that data structure creates data lakes, big data environments, which enables organizations to make some incredibly great business decisions. So we love object storage. It's widely used everywhere in the world for these kinds of reasons. So let's talk a little bit about more. Basic with S3, you can organize your stuff into buckets. And what is a bucket really? It's a container for files that you store on AWS S3. That's really it. And each bucket's going to have a top-level domain space, which means, it'll be easy to find via DNS name. We can give the bucket name up to a 63-character name, including letters, numbers, hyphens, and periods. Keep in mind that even though you create a path in AWS S3, that's not necessarily where it's stored. If you use the slash as a delimiter or something to make it feel like logical storage, remember, it's not regular storage. It just feels like it to us. So keep that in the back of your mind. Now, when we put our data in S3, we've got it secured. And how important is securing your data? If I told you 16% of all hacking events that occur on the cloud are related to missecured S3 buckets, I'm not joking. Misconfigured AWS S3 buckets are one of the biggest cloud security problems in the world that we're dealing with right now. So how to secure your stuff in AWS S3? Well, you've got lots of ways you can secure it. You can use a bucket policy, which is the preferred method. Pretty granular. And it's based on this concept of authentication, authorization, accounting. Who are you? What are you allowed to do? And then keeping track of what you've actually done. So kind of keep that in the back of your mind. Now, you can also use access control list type things for S3 buckets, which is your typical Unix permissions, Windows permissions, read, write, full control, etc., etc. So when you secure your data, you can do it via an IAM policy, which is very granular, and you can determine that Chow can access this, AJ can't, up and running can, Brandon can't, Muzi can, Mufaz over there in Nigeria can, et cetera, et cetera. Jim in the US is my student can. We can do that. So that's what we're talking about. That's one thing. Now, when we store our data, not all data storage is the same. And here's the thing. There are certain types of data storage that are more expensive. There are certain data storages that are slower. It's really about getting the right thing that we need at the right time. So with S3 storage clears, we're dealing with multiple storage classes. We're going to start we'll talk about S3 standard. We'll talk about S3 and frequent access. Then we'll talk about S3 and frequent access one zone. Then we'll talk about AWS S3 intelligent tiering. We'll talk about AWS S3 Glacier flexible. And of course, we'll talk about Amazon Glacier instant retrieval as well, because these are the things that you need to know. So let's talk about S3 standard. Your basic, high performance, high durability, high standard. Use this for stuff data you're going to access frequently. Why? You don't pay to use it. I mean, you pay to store your data, but you don't pay to retrieve it. So for data that you're going to send and receive a lot, this is your thing. It is S3 standard. Now, it's all great, right? But let's say you don't need to access your data very much. And organizations generally have data patterns. So I make a new YouTube video. Chris and me and my team, we play with it for about 48 hours. Then after we're done with it, we archive it in a place where we use it possibly for a period of 30 days. And then after that, we never keep it again, but we save it just in case for prosperity. So what is S3 and frequent access? So let's say Chris and I keep our videos on standard S3 for a week. And then after that, we're probably never going to use them, but we might, so we're not sure. We move our data off of that standard place where we're paying the most money, and we put it on infrequent access. And now we pay a lot less to store our data. But now we pay to retrieve our data. So if we don't pull the data very often, this gives us massive cost savings. So if we use it all the time, we put it in standard. But if we store it and don't access it frequently, but need to be able to access it immediately, we stick it in AWS S3 and frequent access. And we get a cheaper rate, but we have to pay to access our data. So for data we don't use a lot, it's cheaper. For data we use a lot, we can't use this. Now, let's say you were less concerned about your data being available when you need it and you didn't use your data very often. Well, that gets us to S3 and frequent access one zone. And here's what they do. And I don't recommend this. They put your data only in a single data center versus two. What's that mean? When you need your data, it's not going to be there, potentially. So reduced availability, wouldn't recommend that. But it's cheaper, and you pay to retrieve it, and it's instantly available. So AWS S3 standard, normal for data you're going to use all the time. S3 and frequent access, data you're not going to use frequently because you have to pay to access it. S3 and frequent access one zone, data you don't access frequently, but guess what? It might not even be there when you need it, so you're going to get a reduced price. Now, if none of those sound like really great options for you, we have something called S3 intelligent tiering, and this is pretty useful. What happens is you put your stuff in S3 intelligent tiering, and it monitors your data. So data you're using a lot, guess what it does? It puts it into S3 standard. Data that you don't use gets put to S3 and frequent access. It moves your data around to give you the best pricing, theoretically speaking. It's completely managed by the cloud provider, and hopefully it works. Now, going down the cost path, the next thing we approach is S3 Glacier Instant Retrieval. And this is where you're going to put your stuff you're not going to use for a period of time. So it's low cost, long-term storage. Now, the good news is if you don't pull your data frequently, S3 Glacier Instant Retrieval is 68% cheaper than S3 and frequent access if you don't retrieve your data in 90 days. But remember, there's a retrieval fee for your data. So keep that in the back of your mind. Now that we talked about the S3 Glacier Instant Retrieval, let's talk about the traditional Glacier. And Amazon now calls this Amazon S3 Glacier Flexible. Now, this is really for archival purposes, stuff you don't use a lot, and it's got a vault lock option. And what does that mean? It means you can make your data immutable, meaning it can't be changed. Meaning, if I've got a medical record and I want to put it in an immutable vault for somebody to investigate later, like a regulatory environment, it's perfect. I've got to store customer chat transcripts from financial application, I can put it here. It can't be changed, it's immutable. So it's perfect for information that's accessed 1 to 2 times per year. You can retrieve your data in minutes to hours when it's needed. And it costs less. It's 10% less than S3 Glacier Instant Retrieval. But you're paying for data retrieval, and you must request access to data when you want it. So keep that in the back of your mind. Now we'll talk about S3 Glacier Deep Archive. Now this is your lowest cost storage. And it's really designed for archiving data that you can't receive within 12 to 40 hours. And that's why it's giving you the bargain basement price. It's designed for information that's not accessed more than annually. Your data is stored in 3 or more availability zones. So it's stored, and it's designed for long-term storage. Beautiful for heavily regulated industries. So what we're going to do is we're going to start talking about lifecycle management, versioning, and a whole bunch of cool things like encryption. But before we do, we talked about S3 and storage for 20 minutes. So I want to open it to some questions. Where is the AWS RDS data stored by default? So Slajith, we're going to talk about lots of things. Traditionally speaking, it is stored on an EBS volume. And that's realistically the only thing that we can store our data on is block storage for these environments. But understand that there's some idiosyncrasies and challenges of using some of these managed databases versus not. And we'll cover when to use the managed databases versus when to build your own when you're dealing with high availability, high performance, high security environments as well. So we'll cover that also because I feel like it's super important for everybody while we're here. When we get to the database section. Which type of storage is network storage? Well, the storage that sits inside your server, which is technically file storage, is not network storage. But file storage could also be network storage if it's a file server. Difference between S3 intelligent tiering and object storage intelligently locating your data based upon utilization. None, Eva. That's exactly what it's doing. It's intelligent relocating your data. Does the cost money fee for using S3 intelligent or provided by AWS for free? There is nothing on AWS that's for free except for the little mini access they give you to their systems for the first year. And like every other environment to get you addicted to their services, they typically offer you a really good discount for the first year and then raise your prices. Most cloud providers do that, just like any other cable company. And that's one of the reasons why it's always best to go multiple places. Pat Jr., is the provision IOPS SSD with max volume or max throughput still considered slow? Well, Pat, I'll put it into context. Tomorrow or today, go to Best Buy, and for about $150, I want you to buy a Samsung 980 Pro NVMe drive. That drive for about $150 will give you about 1 million IOPS. Now I want you to compare that to an IO1 provision IOPS fast drop volume. The fastest you can get is 64,000. So that $100 drive that you can buy, or $150 drive at Best Buy, is about 20 times faster than a provisioned IOPS volume. Now, Pat Jr., they just came out with a woohoo, super fast, up to 250,000 IOPS. And if you put 4 of them together in RAID 0, which is probably going to cost you $5,000 or $6,000 a month, you can now approximate the performance of that $150 drive at Best Buy. So you do the math. So when I've got some servers in my data center. The servers have 8 times 8 terabyte NVMe drives, and I'm getting about 5 or 6 million IOPS. So that's what I'm getting, and that's what the servers are doing instant storage-wise compared to what they're actually getting in block storage. So slow. Now, does the price change based on the amount of data you retrieve, or is it per request? It's both. You pay per gigabyte. So it's how much data you're retrieving. What's the best solution to store unstructured data? Well, you can store unstructured data in file storage, real great. You can store unstructured data in block storage perfectly. You can store unstructured data in object storage, and they're all good. You can store unstructured data in a NoSQL database too. So the bigger question is not the lightning strikers, which is better, is what is the use case and what do you want to do with the unstructured data? So, and Peter, yes, Pat Jr., RAID 0 is not fault tolerant. So what do we do when we're on the cloud because it's so pathetically slow? We create a RAID 0 environment and a backup RAID 0. So we're ultimately running RAID 10. So we may need 15 to 30 times the number of drives in a cloud environment that we actually would in the data center just to equal the same performance. Is the data stored in S3 buckets encrypted? Not by default. You have to enable it. Now on Azure, it's encrypted by default. Is there storage limits on the type of data? That's one good news about the cloud. For the most part, there's almost no storage limits, but you will be paying for it. Mufaz, you can use all you want all together at the same time. You can do some manually and use some intelligent tiering. Absolutely. Is there extra cost involved in encryption? I don't believe so. Can we use S3 in front of EFS? No. because Naga EFS is a network-based file system, and it's used to servers to access data. Servers can't use object storage to access data, so no. If we need 10 servers that need to access the same data at the same time, in a Windows environment, we're using a server message block protocol. And in a Linux environment or a Unix environment, we are using network file system. Now, the network file system is what we're using. Now, AWS has their brand of network file system called EFS, but it's really the network file system we're using. And we need to understand that it's the network file system, because if we're using Nutanix, it was going to be the network file system. And if we're using any of their clouds, it's all going to be the same thing. So we can't memorize some silly name of a service. We must know the actual technology it is, because it's the same technology we work with in all clouds. Saeed, Ahmed, S3 does not have any file system in place because it is not real storage. It is object storage. It's flat storage with like a database structure. What's the difference between durability and availability? Great question. Availability is it ready when you want it? So a system that's 99.999% available means it's up and available for you to access, all but 5 minutes and 15 seconds of downtime per year. That's availability. Durability is if AWS is down, their whole cloud's down for a week, the data will still be there when it comes back up. So durability means how the chances of it going away permanently. The more durable, the more permanently it's there. Said, Ahmed, can you do structured versus unstructured? Sure. Structured data is Ahmed buys something for 600 dirham. And then the next person buys something for 400 dirham. That's structured data. Now, what is unstructured data? I go to Dubai. I take some photos at the Gold Seek. I then go to Sheikh Zayed Road and stay at Emirates Towers for a couple of days and store some photos of that. That's unstructured data because there's nothing that's got any structure to it. Richard, what kind of data do we store in a database? Well, I don't think we ever should use the term RDS or DynamoDB, and we'll talk about lots of reasons why you wouldn't want to do that when you deal with a customer, and why that may be the worst opportunity. But what kind of data do you store in a relational database? Things that are related to each other, such as price and an email address, or price and product that's sold. What do you store in a NoSQL database? Either the same kind of data, but where you need extreme scalability beyond what you can get in a relational database, or unstructured data. But there's some good reasons, Richard, why you could never use DynamoDB in a practical architecture or any of the RDSs. And there's other ways where if you're doing an AWS proprietary only architecture, you could use these things. But realize any of that proprietary stuff really causes a problem in multi-cloud. And we'll talk about what to do multi-cloud in real architectures and why in most cases we can't use a DynamoDB. Well, it's good for certification, but not for reality. We will talk about that. And there's some great things about DynamoDB because it's also a great database. And we'll talk about when to use them as well. So with all these things, there's trade-offs. And the job of the architect is not saying, hey, this is cooler than this. It's saying, I can't use DynamoDB or RDS in any of these architectures for these 87 reasons, but I need to use it in this architecture for these reasons. Can I shed more light on a storage area network? A storage area network, they're basically big boxes that are filled with hard drives that also have a network. And either they run a separate kind of network called fiber channel, which plugs into fiber channel ports in the back of servers, or they use the iSCSI protocol. And basically, we have things that are machines filled with hard drives that are attached to the network, and that's where we attach things. How do you check any file? Any encrypted file will have a hash. The hash is a mathematical algorithm that takes the data, runs it against something, and the hash shows that the data has not been checked. It's called message integrity and hashing algorithms. When to use databases? We'll have a whole section in day talking about databases, and then we'll talk about what kind of storage to use with the database. But right now we're talking about storage, not databases. Okay, let's get back to the actual content. So let's begin by discussing lifecycle management. And I described how organizations use data for periods of time and then they don't. So let's look at this particular environment. Really what I was trying to show you was what's on the bottom. And I know I did some messing up with my OBS when I was trying to play with some slides before. So let's say we have a data that we use constantly for 30 days. And then what we're dealing with is we use it every day for 30 days. Then after 30 days, we almost don't use it at all. So we migrate it to S3, S3 and frequent access. And let's say we use it there for 30 days, like twice a month. And then after that, we never use it again. So we can set up a lifecycle policy that we can manually configure that will take the data and move it automatically. So that's something I wanted to talk about. Now, and I told you object storage by default, the second you make an object storage environment, what's going to happen is every time an object is modified, it creates a new version. Now, AWS disabled the default object storage on their own. So, kind of keep that in the back of your mind that AWS disabled it. But normally, always speaking, what you're going to find is you're going to get a new version every single time something has been created. So think about this. You've got a document. We store it in S3. I save it again, I save it again. Every time I get another version. Now, this is the default behavior of object storage. AWS overrode the default behavior and automatically deleted your old versions for you. And then they created a new cool feature that lets object storage do what it did, which means they basically just don't remove your data. So that's what we're dealing with regards to object storage. Versioning. It enables us to keep multiple versions at the same time. And this is super cool because if version 154 gets corrupted, you can go back to version 153 or 149 until you find a non-corrupted access. Awesome, 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 awesome. Next thing I want to talk about is multi-factor authentication delete, because we can do this. So think about this. I want to go delete something, and I'm pretty sloppy with my keyboard, and I click a run button. Whoops. So, or better yet, all of these people here are really, really nice in this group, but somewhere in this group, we've got an evildoer that wants to hack us. So this evildoer decides to delete one of the objects in my S3 bucket. He goes, poof, click. Now, instead of the object being deleted, a challenge gets sent to me. And it says, here, enter the special one-time token or password. I provide that token. And if I provide the token, it's deleted. But if I don't provide that token, or if I didn't initiate the delete, I don't give the token and the object doesn't get deleted. So S3 multi-factor authentication delete will really, really, really save you. And it will help you, keeping you from deleting things that you won't want to delete. While we're at it, AWS added a new feature to help you. It's called the recycle bin. Be wary of the recycle bin. And here's why. I've got data. I want to delete the data, but now I delete it and it goes into the recycle bin. If I don't empty the recycle bin, I'm still paying for the data. So the new AWS recycle bin that was there, guess what it does? It keeps your data on the cloud so they can keep charging you until you delete it a second time. So kind of keep that in the back of your mind. So now let's talk about organizing our data. Remember, AWS does not store files in object storage. It's not real storage. It's not hierarchical storage. Not at all. So it's flat storage with a pointer to the storage, just like a database. But your users don't know how to think like a database. And since your users don't know how to think like a database, if I wanted to make it feel like hierarchical structure, what I could ultimately do is I could store my data, and I'm going to paste it into the chat box so you can see it. I can use the delimiter where it says like Mike/2020/AWS video/storage/s3.mp4, and it looks like a folder. And I can store all my stuff in that folder, and it looks like a folder, but it's not a folder. But it makes me feel good. It makes my users feel good. So kind of keep that in the back of your mind. So you're going to store stuff. You're going to put data on S3. Now, you stored your stuff on S3. You got a bad guy or girl. They break into the AWS data center and they store all your hard drives. Ugh. Uh-oh. Now, the data that's stored on the hard drive is not encrypted. So I break in. Child gets into that data center. She takes the hard drive home, and she sees there is thousands of photos of my cat Cindy. And child decides to surprise me and make a beautiful cat calendar. Why? She could access the Cindy photos because they weren't encrypted. So if we want to make the data unusable to anybody that sees it without a decryption key, we can encrypt it. So encryption, we make it unusable unless you can decrypt it. So typically the way it works is this. I take my data, I encrypt my data, and after the data, I get decrypted to use it. So how do we encrypt our data in the AWS cloud? What do we do? What do we do? What do we do? So the first thing we can do is we can deal with SSE-KMS, and this is a custom managed key with the AWS key management system. So this is a relatively simple, complete key management solution. And here's what happens. You got a user that manages a master key, meaning we set up the master key ourselves. Then we've got a key management system that manages the data key. And the key management system will provide an audit trail of who, when the data was accessed. So our first option is we use the SSE-KMS. I didn't make up those terms. They're test terms. SSE-KMS, that is a customer managed key with the AWS key management system. The next system itself has a complete key management system from AWS. Now, if you're in a high security environment, they probably won't let you do this because this is where AWS manages all your encryption keys and they own them all. So they manage all your encryption keys, they rotate your keys, and every object is encrypted with a unique encryption key. It's a good encrypted solution, but somebody else owns your keys. So if you're in a high security environment, this won't be tolerated. Now, the next option is what you'll use in a completely militaristic security environment. And this is going to be the SSE-C, which is a customer provided key. And here the customer has complete autonomy of their encryption key and they manage them. So this is going to be labor intensive, but this will provide the best security options. Let's talk a little bit about tuning and optimizing S3. In this section, we're going to talk about pre-signed URLs. We'll talk about multi-part uploads. We'll talk about range gets and cross-region replications. Pretty cool stuff. So what is a pre-signed URL? Well, everything you put in S3, if you set up your S3 bucket right, is private and secure, which means nobody can access it. So now, I want to give Chow and Abigail and Brandon, because they all have blue wrenches, access to my S3 bucket. So I've got an option. I can create an account for them in my bucket and they can access it. I can do that. Or I can simply take the data they want, sign it with my own encryption key, and send it directly to Chow, Abigail, and Brandon. And if I do that, guess what? They can access it. All they have to do is click a download key, and they received it from me. So this is a very simple and a secure way to sign something that somebody can have access to. And I can do this with my encryption key. I don't have to give any decryption keys to anybody else, and they can just download it because they have the link. So somebody sends you a URL on Google Drive, it's a pre-signed URL, effectively speaking. So kind of keep that in the back of your mind. So when you pre-sign something, how long do your signatures last? Well, it depends how you signed it. If you sign the URL with an IAM instance profile, it's going to be good for up to 6 hours. Now, if you signed it with an AWS token from the security token service, it's going to be good for up to 36 hours. Why? Well, an IAM instance profile is less than a token that's, one time. Now, if it's in the user account and I give it to a user account, child's account, guess what? That's good for up to 7 days. And if it's a temporary token, how long until the token expires? Guess what? It's not going to be that long. So that's what and how we're using. Now, let's say we're dealing with pre-signed URLs. Let's say we're talking about big files. So now I want to send Chow 100 gigabit photos or gigabyte photos of my cat Cindy. My cat Cindy yesterday was chasing a rat outside and she was cute. And I took a 20-minute video and I want to send it to Chow, Chow's S3 bucket. Now, I got this big 100 gig photo. Now, when I try and transfer a 100 gig photo, a lot of stuff can happen. I can have some packet loss on the internet and get 3/4 of the file there. And guess what happens? The last part doesn't go. I could get 98% of it and lose one thing, and the whole thing is lost. So what we want to do, we've got a big file, a file over 100 megabyte. And S3 will allow you to upload an object that's up to 5 gigabytes. Now, it'll let you store much bigger files there, but for backup and archival purposes. But uploads, you can do go up to 5 gigabytes. You try and upload a 5 gigabyte file, and all kinds of stuff can go wrong, especially over a slow or an international connection. So if we decided to break it down into smaller pieces, we took our file and we made it multiple file parts. We can basically send this one and this piece and this piece and this piece. And then on the far end, we reconstitute the pieces. Piece 1, go. Piece 2, go. Piece 3, go. Piece 4, lost. Piece 5, gotten. Piece 6, gotten. Hey, wait, piece 4 is lost. Just retransmit piece 4 and not the whole thing. So that's what we're dealing with regards to multi-part uploads. Now, the last thing we want to talk about is something called cross-region replication. And I want to show you that as well. So, got an S3 bucket in Ohio. I've got a lot of data and customers in Japan. Well, what if I created a bucket in the US and another bucket in Japan, and I replicated the bucket between US and Japan? Well, that's what do I got? More availability. I lose one bucket, I got another. Data center goes down, I got another. When you're dealing with the cloud provider, they charge you to send data in between regions. So what if you've got users in the US and Japan that are using the same information? If we can copy the data to both places, then we can work on the data locally, which will reduce our inter-region data transfer charges. So that's really what we're talking about here, is what we're trying to do. So that is cross-region replication. I will briefly touch instance storage, and then I will open it up for questions. And we will start tomorrow with a big discussion on block storage and how to make it work, how to improve it, et cetera, et cetera. But let's talk about instance storage. So when you get to server, inside the server, it's got a hard drive. Now, when you're dealing with big servers and powerful servers, they typically have RAID arrays. A RAID array. And say in the back of your server, like my servers that I use to run my cloud, all have 8 times 8 terabyte NVMe drives. I pop them all together in RAID 0, and I got another one backing it up, and another RAID 0, so I effectively have RAID 10. And by doing that, I've got 64 terabytes of high-performance storage in my servers. Now, that is low-latency servers, and that's perfect in a normal server. VMware Workstation, VMware ESXi server were good. Now, all of a sudden, I convert my data center to a cloud. Now, the cloud's looking for the storage somewhere else. So the storage that comes inside of a server in a data center is normally used. But when we go to the cloud, the storage that sits inside the server is not as volatile, meaning it goes away with instance termination. So We can't use the storage that's inside of the server in the cloud as storage, because even though it's the fastest, even though it's the highest performance, it goes away upon instance termination. So it's volatile storage. So we can't use instant storage for anything at all in the cloud, other than maybe to boot the machine. So tomorrow we're going to start at block storage, but I want to make sure we go through and answer some questions. I left about 15 minutes in the end for that reason. So let's, Chris, if you want to bring in some questions. One thing that I will say is I wish I could, but I have no control over bad people coming in and trying to leave horrible messages, such as the people that we keep blocking. What happens is we block them, but there are so many bots that are out there, you can't completely block bots. And thank you, Chow, for deleting that horrible content as fast as you did. How is lifecycle management then intelligent tiering? Well, lifecycle management is you, the systems designer, being smart and planning it. Intelligent tiering is letting the technology do it for you. I will tell you one thing. When the technology does it for you, it never does it as well as when you manually plan it out ahead of time. So I would use intelligent tiering for stuff that I didn't know. And I would use lifecycle management for things that I knew that were predictable. Can you recycle data that was set in lifecycle management? I have no idea what you mean by that. Meaning, can you get the data back? Absolutely, you can get the data back, but I don't know what you mean by recycle. Is S3 versioning another way of saying data is immutable? No, it has nothing to do with it. Immutable means the object can't be changed, and it's locked up in a vault. So if you gave me a disk and I stuck it into a physical safe and didn't give you access to the safe for 10 years, that's immutable. What versioning is, hey, you got a document, you create a new version, it creates a new version, you edit it, it creates a new version. It has nothing to do with immutable. Does the recycle bin create orphan records with the data? Brian, I don't know what you mean. To answer that. Is there a way to permanently delete the data so that it doesn't go to the recycle bin at all? I know you could. I haven't tried to configure it afterwards. So that's the thing. As an architect, we don't touch the technology. We design it. Our engineers do it for us. And I'm sure there's a way we can permanently do it without it hitting the recycle bin, but it's not something I do on a daily basis. And news, does AWS retain data? They retain data, but they're not going to tell you how long they retain it. And as a rule, if you accidentally delete your data, they're not going to give it back to you. So no, it's up to you. You delete your data, it's lost. That's for the most part. Chris, you can go to the next one. Key management system, it manages your encryption key, which is different than a place that enables you to store passwords and things like that. So they're totally different. There's a fee on all data that's being transferred between regions, etc., in the cloud. So the question you have to think about is, which costs less, replicating your buckets or constantly sending your data across the region? That's what you have to determine based upon your data usage pattern. Okay, you can go to the next one. Does cross-region replication improve latency or just availability? Both. So, got a user in the US, wants to reach something in Japan. Might take 6 or 7 milliseconds to reach there. But I got a user in the US, it might only be a millisecond to reach them. So yes, the closer your data is to you, by far, the closer we'll do this. I do see somebody is asking a question on data lakes, and we will talk about data lakes when we talk about databases and data structures. But since we're talking about storage right now, it wouldn't be the appropriate place for us to talk about data lakes. But we will talk about it in the database section when we actually get there. Manoj, if a bucket in region A is updated, will the bucket in B update in real time? Well, it depends. If you've configured cross-region replication, the answer is yes. And if you have not, it won't be updated at all. So that's up to the way you set it up. It's a great question. How do you choose between multi-part uploads and transfer acceleration? You would use both. They're totally different. Transfer acceleration gives you a little bit of network performance by sending it to a local region and having it auto transfer. And multi-part uploads enable you to split big files into small parts. So you should be using both. They're not mutually exclusive. Chris, you can go to the next one. Chris, we've already dealt with that one. Where can instant storage be used? Anything that you don't care about that's going to get lost. So pretty much that's it. Does a pre-signed URL give read-only access? Yeah, but it's really based upon the way you signed it. But it's generally read-only that you're going to pre-sign. Can you configure intelligent storage? Intelligent tiering? Of course you can. It's one of the features. But then again, I don't know what intelligent storage is. It's just somebody else's name. Difference between block storage, file storage, instant storage, object storage, and a summary. Instant storage, the hard drives that are there inside the computer that go away every time you kill an instance. So totally unusable for you. File storage, the hard drive in your computer or a file server. Object storage, you take data, it's a storage area network. You take your data, you break it down into objects. Each object has metadata about it, and you can use object storage for backup purposes, static website hosting, software distribution, and archival. That's all object storage is good for. Block storage. Type of storage area network where your data is broken down into blocks. Block storage looks and feels when the data is written similar to a hard drive, so it's used as network-based storage by virtual machines, etc., in the cloud computing environment. Chris, you can go to the next one. Said Ahmed, object storage does not use the file system. How are the data blocks? They're not data blocks being placed on the disks because it's not. There's not. It's being converted into objects. It's object storage. Object storage doesn't use blocks. And each object has metadata. You can just search for the metadata and you can find it. Chris, you can go to the next one. You have to enable it. Does it mean that it's impossible for a third party to permanently delete a file that has been versioned? Anybody can delete a file that's been versioned. Anywhere, anytime, as long as you have access to a bucket. So, no. Versioning just means that if you delete one version, you may have 8,000 other versions that you can go back to. But somebody can delete all 8,000 versions and you don't have any of them. Nothing's impossible. Chris, you can go to the next one. S3 has unstructured data. Can we say it is a data lake? Absolutely not. A data lake involves taking information out of a relational database, a NoSQL database, a data warehouse, streaming data sources that typically need some Python Spark script to manipulate the data. The data then needs to be cataloged and mined. And then after that, we can create a data lake through several stages of cleaning and manipulation and mapping and reduction. So way, 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 way more than just unstructured data. And then, Chris, we can go to another one. Nope. They're two different services. Glacier Vault is something where it's locked down. So now they're different services. Anytime you've got a different name from AWS, you've got a different service. Chris, you can go to the next one. And many of these services are similar. Okay, I think we got one or two that just popped in. The one is reasonable. How can the S3 bucket be used for hosting? S3 bucket can be used for hosting because basically you pop that, you connect it to the internet, and it's just basically files. So the same way you would have like a web server that has an index.html page and a couple of pictures, you could just stick that in object storage, connect it to the internet, and it's viewable. Okay, this is 100% outside of certification. If you're interested in learning how to build an enterprise application integrated with the supply chain, first thing is not cloud architecture at all. You're dealing with application architecture, which is a totally different career. So if you're interested in learning how to be an application architect for supply chains, I recommend an application architecture course. And I also recommend you master supply chains, but this is a cloud computing thing. And cloud architects don't code applications. They don't design applications. They code end-to-end systems. So since I'm a cloud architect and not an application architect, it's a career that I don't know anything about. I only know my career. What kind of questions can you expect in S3 and the exam? I would strongly recommend you get a practice test. And we will recommend that in the book that you downloaded. And you will also recommend it in our course. So understand for all of these things, what kind of questions you can expect. You can expect a bunch of stupid questions. Stupid questions related to the key management system, questions related to migrating data, questions related to intelligent peering. For the most part, any kind of question that they can possibly think of, which is why we recommend a practice exam. I will tell you the exam is not challenging, but they are completely irrelevant questions for those of us that actually work as architects. But having said that, it's not going to be hard. Get yourself any practice exam. My friend Haman Shara runs a company called Review and Prep. For about $20, you can get a practice exam. Get used to answering these questions. Andrew Brown's got a great practice exam as well from Exam Pro. Get a practice exam. How do you provide cross-account access? When we start talking about cross-accounts and IAM roles, we will definitely talk about that because it's a great question. But that's an IAM section. Okay, so couple things I want to go over. For those of you that are interested in things beyond certification, like actually getting hired as a cloud architect, we have a cloud architect career development program. And for 2 more days or 3 more days, we have a 30% off sale. So if you're trying to get a job as a cloud architect, you can always take our cloud architect career development program. Leo from my team popped a link to that along with the 30% coupon code. Tonight, we're going to have a really fun Head in the Cloud show with me and my buddy Alonzo and Eva Tennant. She is a fantastic cloud architect who is a pharmacy tech and an EMT first. She lights up the room. She's got so many cool things. It'll be a fun discussion with her tonight. Please join me and Alonzo tomorrow. If you don't have access to the book, please download the book. And the show with me and Alonzo and Eva tonight is tonight at 6 p.m. Please join. If you guys want to sign up for the class, I'm saying some of these things we'd love to work with. We would love to train you. We can't wait till you're all cloud hired. Our focus as a mission as a company is we get all of our students cloud hired. We don't quit on our students. We give them a year in our program and they get hired. So if you want to work with us, we'd love to work with you. But no matter what, we're here with this week with completely free AWS Certified Solution Architect Associate Bootcamp. And tonight we've got some things, and if we need to get deep into something real techy, who knows, we may have a breakout session. We have labs for all of you that desire to do so. And yes, I would consider this a real beginner cloud course compared to what we would do with the people that we actually get hired as cloud architects. I would tell you the certified solution architect professional is about 5 to 10% of what's necessary for these jobs. And I will tell you, this is the associate / professional. It's like associate and 3/4 of the professional at the same time. So they're there. Now, tomorrow morning, we have a completely free cloud architect career question and answer session. So if you want to know anything about building your career, I'm going to come online tomorrow morning for 2 hours completely free. And on Thursday, you know what? We're going to have our How to Get Your First Cloud Architect Job webinar. And it's going to be on Zoom, and it's going to be 100% career focused. We'll tell you what needs to be on your resume. We'll tell you what the hiring managers care about. We'll show you how to get a job when you don't have experience, things to communicate to the hiring manager. Everything we do is about getting you cloud hired. And yeah, go out there and do it. And go out there and get yourselves cloud hired. So hope to see as many of you as possible tonight. We love working with you. We love seeing you here. Please tell a friend. If you haven't hit the like bell or commented or subscribed, please do so. If you've got some friends that mix this, please share the word. Connect with me on LinkedIn. Chris, pop my LinkedIn thing for people to follow us. We put out 50% of our content on LinkedIn and 50% of our content on there. And click that show, Head in the Clouds tonight, and join us. Hit the reminder. You don't want to miss it. We have a lot of fun on this. And so there you go. So hope you all had a wonderful time. Can't wait to see you all tomorrow. Join us tonight for the Head in the Cloud show with me, Alonzo, and Eva. Eva will light up the room. She's fantastic. And to close out the day, if you can give me a hashtag. Actually, before we do that, if anybody wants to connect to me on LinkedIn, Chow just posted my link. Please do so. And then for all of you, at the end of the day, if you can give me a hashtag cloud hired. And see you all tomorrow. Love seeing how many people are still here, awake, alert, and oriented. Love how many people are all over the world. I'm looking at these names. I see people in India, Africa, Pakistan, the Middle East, Asia. This is just so cool. All over the US, South America. And then let us know where you're at too. I know Sean's from Trinidad, living in Germany, which I think is totally cool. Leo's over there in Brazil. Robert, I think, is in Arizona. I'm over here in South Florida. E.T., it's good to see you. I know exactly who you are, Elvis. I'm happy to see you. Yeah, please connect to us, Soothing Relaxations on LinkedIn. And let me tell you, I bet you I already see a whole bunch of things. I have. Please, feel free to connect. 1,000 people connect with me, I'll take 1,000 people. I just want you all to have the best careers. And if I can do something along the way, we're thrilled to do it. Berlin, London, Connecticut. This is just so wonderful. I love, we get so many wonderful people, so many parts of the world. So make sure you've got access to everything. Plan on lots of cool stuff. Claudette's in South Africa. Ellen is in Cameroon. I mean, I'm loving this. Saeed is in Dubai. I saw your name, Ahmed. And I figured you'd be in the Middle East over there, but I loved all my time spent in Dubai, and I was the lead architect for the Dubai Marina project, the voice data video. Dare has obviously got a Nigerian name, but is in Glasgow. The links will be provided every single day. We got people in Florida, South Florida. Come visit South Florida. Please come visit in South Florida. Philippines, Dubai, Australia, Lagos, Nigeria. Bro, this is amazing. That's why I love doing these free AWS Certified Solution Architect Associate Bootcamps. We've got people in the Netherlands and Abu Dhabi. I mean, this is just great. And why do I love it? I love watching all people from all over the world get together to truly, truly help each other build better lives and careers. I love it. And that's why I do it. What time tonight is going to be 6 p.m. Eastern time, which is 11 p.m. UK time, and 3 p.m. for those of you in the west coast of the US or Canada. Australia, India, Nigeria, Canada, El Salvador, Cameroon. I mean, it's just incredible. Thailand, love that. India up and running. Abu Dhabi, haven't been there in a while. I haven't been in India in a while either, and I need to get there. Atlanta, South Africa, wow, love that. UK, more India. Mozambique, I'm so happy to see it. Liverpool. Eddie Patrick's over there. I know Eddie real well. He's fantastic. Canada, El Salvador, North Carolina. You're in right now, Abigail. That's fantastic. Canada, Abigail, we got to get you moved to Florida. And yes, as Chell is saying, there's all kinds of free stuff and cool stuff in the description box below. So go out there and get it. Go out there and get it. Join us tonight at 6 p.m. And if you've got any career questions, join us tomorrow morning. Okay, Calp Sunny, can I show some light on the Cloud Architect Professional course, like the timings, etc.? So Calp Sunny, you may see some of our people. So this week, I will tell you that I got a pastor hired as a senior cloud architect as his first tech job. I will also tell you that 4 people. I got one person an enterprise architect job this week. One person got a major architecture promotion, and another person. So it's been 4 people that are our students, and one person told me on YouTube that the videos I made helped them get hired. So, we've only gotten 5 people so far hired in the last 2 days, but I figure that's pretty good. So, we'll take that. What do we do in our paid course? Well, our paid program is approximately 500 hours. And in this course, we really teach people how to be an architect, how to design the architectures, but it's not just designing. See, as architects, we're very special in what we do. We start with the CEO of a business, and we ask that CEO about the business, about their business goals, their business pain points, their business challenges. From there, as architects, we design a technology solution to go solve those business problems. And then after we design that solution, there's typically a proof of concept, or we lead the proof of concept, and we bring in some engineers, and they do the proof of concept, and we lead the team. Then we present that architecture back to the customer. We help sell that architecture back to the customer, and then we go our merry way when somebody else builds it. So in our Cloud Architect Career Development Program, we teach you how to present like an architect. We teach you how to write like an architect. We teach you how to interview the client to get the information. We teach you how to be relevant to the CEO, CFO, CTO. We teach you how to present in front of a 1,000-person audience, because you will be doing it. We will teach you what goes into a white paper that you have to write. We will teach you how to interview and how to negotiate. Then we will teach you how to be a cloud architect. We will teach you how to do cloud architectural design. Now, obviously, inside of that, we have to make sure that you're an expert architect. Then we have to give you the leadership skills and the sales skills to do it, and even help modify and tune your resume, because if you have an engineering resume, you won't be hired as an architect. So we've got to really basically do all those things to get everybody hired. And that's what we do. Now we have live training, and the way our training works is we have 3 live classes per week. And in the live classes, out of 2 of these 3 classes, we teach architecture, we teach the leadership skills 1 day a week. So we have 1 class that's on 9 a.m. Eastern on Tuesdays, which is 2 p.m. UK time. The next class that we actually have is as follows. It is on Thursday at 4 p.m. Eastern, which is 9 p.m. UK time. The 3rd class that we have is actually Friday at noon Eastern, which is 5 p.m. UK time. And we record them all in case you can't be there. So in those classes, we do that. Now, in between classes, there are several hundred hours of videos and homework assignments for you to do to become a great cloud architect. And you will turn those assignments in via Slack, and we'll give you feedback on them. And then, Sony Calp, there's labs. Now, even though we cloud architects don't configure, we design. Everybody wants to know that you have experience. Now, if you tell a hiring manager you set up a WordPress website, guess what they say? Yeah, so I don't care. If you tell them you set up an EC2 instance or an S3 bucket, guess what they're going to say? I don't care. So we do a separate kind of labs. The lab we do first is we have our students build every component of the data center that makes the cloud possible. Our students set up server virtualization, containers, build firewalls, VPN concentrators. They set up file storage and NFS, and they go through it all. Then our students build an Active Directory server. And then, Calp, 100% of our students build a cloud. Not a VPC, a cloud. Every one of my students builds a cloud. And why do I have every one of my students build a cloud? For the following reasons. After you build the cloud and you can build AWS, Azure, or Google by yourself, you're much more hireable by the hiring manager. But it's not just that. The reason we did this was one more thing that we need to do. Hiring managers want people that are energetic, enthusiastic, and passionate about technology, that are willing to go above and beyond, that are great team players, that know what they know and they don't know. So Cal, we train you as a cloud architect, and you've got a job description and a job title from Go Cloud Careers because we give you all an internship. And you talk about designing and building your own cloud. Now, you're in a competition and you're talking about building your own cloud and designing clouds. Your competition saying, I set up an S3 bucket. Now, who's more energetic, more enthusiastic, more motivated, and more capable? You that built the cloud. So those are the way we do our training. And if you'd like to train us, we'd love to work with you because we have no issue getting people cloud hired. And I will tell you this, Omar Weaver, congratulations. I look forward to working with you. I left practicing medicine and became an architect. This week I had a pastor. He's a very nice pastor. His name is Ronald, who just got hired as a senior cloud architect as his first tech job ever. So I've had lots of people go from waiters that are hired by AWS. I've had people that do geospatial imaging and look to determine where to drill oil that are hired by AWS, and we can help you get hired too if you desire. So now you know what we do. Connecting from Cameroon, fantastic. Martin, which I always get your name wrong. I know in the Netherlands, we love you and we're thrilled to see you. And we're super excited to work with you, those that signed up. And our discount is good until the 30th. So now you know what we do. Now you know we are. And Tyrone, you left 16 years of new vehicle sales. You're going to be a fantastic cloud architect there in Cape Town or Johannesburg someday really, really soon. So have a wonderful day. See me at 6 o'clock tonight with the show. It's going to be fun. And don't forget tomorrow to ask your cloud architect career questions. And can you get a cloud architect roll of 25? Of course you can. And thank you so much, Leonardo's in our program. I appreciate it. Pat, it ends on the April 13th. And can I share a link to join that course? Ashish Sharma, absolutely. Chris, please pop a link to the course and that 30% discount code again, because the chat box is busy. Leo, thank you so much. And Leo, if you can also provide a link to that course. There you go. So if you'd like a link to the course, you know how to find it. Let's get yourselves cloud hired no matter what you do. So 6 p.m., we're going to have a really fun show tonight, everybody. 9 a.m. tomorrow. I bring in any cloud architect or any cloud computing career questions you have. Want to be a network engineer, architect, enterprise architect? I don't care. I'm going to give you the information to help you get hired. So hope you had a wonderful day. I can't wait to see you tomorrow. Cloud hired, everybody. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers. This is day one of our AWS Certified Solution Architect 2022 course, our free AWS course, and a free AWS certification course. Can't wait to see you all tomorrow. Take care. Cloud hired.